We're doing it. Look at that.
Hey.
Oh. Oh. Twitch.
I hate this.
Do we? So we
Fucking remember me.
Good execution right there. He's had a couple
Why?
nice blocks
Why did this open?
in this ball game in the run game.
Twitch is playing something.
Yeah.
Austin Johnson knocked it out of here. It'll be second down to 10 with
Is this pass even
2:43
run?
left.
Yeah.
This is
The
by Patrick Graham, the defensive
every
coordinator.
time.
Yeah, it's not a new device.
That is the same device.
Is what he likes to
Why?
run, but
I don't know.
due to personnel that he has here in New York right now, he's running a lot more zone looks.
We're running the zone looks.
Get to as they start to put this roster more and more together to their
I
line.
like how you can't even turn off the football stuff it's doing without the code.
Yeah.
Or maybe you can, it just wouldn't log you in. I don't know.
Yeah.
But we want to log in.
13. Obviously, they're going to work Boston Scott a lot here tonight without Miles Sanders in the lineup. Yep. The Giants, they were in zone
Why is
coverage.
it
They
slow?
were giving a two-deep shell. So when you get that, if you've got a guy like Boston
They have a
Scott who
business
can work
about
underneath, he comes out of the backfield.
Real-time live feeds and they can't
That's
send a
nice
code.
luxury to have. He's already got 6 touches. Scott for 43 yards.
I'm gonna mute the tab. I lost the mouse. Where's the mouse? Oh.
Made that tackle, a gain of 4, but hold it. Offset.
There's,
Number
oh,
7.
aha.
10-yard penalty. Replay. First down. The aforementioned Sua Opeta.
Or not!
What?
Wow.
Around a little bit. There by Leonard Williams.
Twitch is prioritized over Chrome.
That was Austin Johnson.
I
That
guess.
he was holding.
Should I
Balance.
try to send it again?
I think so. I feel like it never sends until you do the resend code. And then it sends 2 at the same time pretty quickly.
Wentz out of the backfield.
See, we
catches
pressed
May.
resend like
Yeah.
Okay.
It sends both of them. And I think they're the same code. Yeah.
On 1st and 20.
Oh, they are.
Yeah.
Missed a tackle. Big Ten football returns Saturday. As Justin Fields and the 5th ranked
7,
Buckeyes
4,
take
6,
on
9,
the Broncos.
3, 6.
It all starts with a
3,
special
6.
kick.
Ah, we're in. It stopped the football. Oh no, it didn't. I thought it. So you can just like watch TV on Twitch.
Yes.
That's kind of fancy. Look at that.
Where's
Oh, it says number 2. Should we just change it so it never? So it's just always LEETCODE SPEEDRUN. All right, we'll update it every time.
Alright. How do we get to it's here?
Aha!
Woot.
Look at that.
Beautiful.
We have a green bit rate.
green bitrate.
Yep.
Okay.
So I guess we're good. Oh
Yes.
no, we're not good. We're not showing the right scene.
True.
Default scene.
Okay.
There it goes. We're ready.
Ready?
Yes. Are we going to try the problem 5 again first, or should we start with something else? Let's go.
I want to try my solution.
Try it? Yeah. It feels faster than a stupid n squared, I think.
Yeah.
Unless it's worse than n squared. Maybe it's like exponential. Because at a given depth, you're maybe... No, because they'll be unpalindromic super fast, probably.
What?
Like, every time we try to find a palindrome out from a given point,
Yeah.
I'm sure they'll be broken quickly.
Yeah.
Yeah.
Should I delete this or should I just comment it out?
Comment it out. Add some.
Oh
Oh
my God.
my goodness. That works. I was gonna say add some spacing to separate it, but I guess it's already clear.
Alright. Okay.
So
I'm gonna make the other function.
can we make sure that the recursive thing is always hits all of the points? I guess so. Yeah, we recursively split on. Nope, I don't know.
Wait. Oh wait, yeah. No. Wait, can we just add to this function definition?
What do you mean?
If I want to make this the recursive thing? I add,
Probably
like,
you could if you use like
optional variable?
defaults.
Yeah.
Yeah, I bet it'll take it.
Oh my God, it's my insert. Okay.
Left and right, I guess.
Yeah.
Yeah.
Left
Equals 0.
equals 0.
Do you? Oh, that's weird. I don't like the types.
No, there's no. Maybe there. Wait, I don't remember if there's.
I don't think it matters for that. Unless the equals should go before the colon or something weird. But 0 to -1.
Yeah, because we
Clever.
can't start it at. I assume.
Oh my goodness.
It's so alarming. It's
Aw.
just Amber Alert.
Yep.
Okay.
That's terrifying. We can't do math on the right index if it's -1. Right?
I mean, it won't be a -1.
Oh, okay. No, it's not a -1. Len of S -1. Probably.
Alright.
So, do you always want to just check from the exact middle, regardless of if it's even or odd?
I was thinking, yeah, if we ever encounter the same character, then we just increase right by 1 or left by 1, depending on where it is. Wait, if we're moving out, we should have like a second left and right, right?
Sure.
I'll put that here.
Although I feel like this could be in just a loop, but yeah.
Yeah. Oh, okay.
Python doesn't have for loops, so yeah. Well,
Oh wait, we also need like pal, right? Or not? Well, we should because we want to
no, you could just
short
do,
circuit.
You could. What is it for? For the maximum palindrome that you've seen so far? Or?
Yeah.
Oh. Will that not have to bubble up? No, that'll still have to bubble up though.
Yeah, but that's fine.
But if it's doing that anyway, you might as well do it in the returns.
Uh-huh.
Then you don't need the, like, a given recursive one returns the maximum of its one and to the left one and the right.
Right.
So we don't need pal.
But I want to be able to short circuit. So like if we start in the middle.
Oh yeah,
we
yeah,
already,
sure.
Okay.
Sure. Yeah.
And I don't know.
But then I guess it could just be a length. But yeah.
I don't know if I want to do like return left and then return right. Because then what if you find the palindrome in the left? Wait. Right, because
we'll short circuit.
we don't want to do like 64, 32, 16, 8, 2. We want to do 64, 32, 90.
Uh-huh. Oh,
6.
I see. Can we not do it recursively though?
You might be able to.
Well, I don't think you can tell one recursive thing to wait for the parent's next line of code. Or something.
Well, we can do it where we have like whatever. Oh my god. Maybe this is harder recursively.
Yeah.
Should we just not?
I mean, yeah.
Yeah.
Do a stack of like next window stack, which is like a list of tuples.
Next window.
Yeah.
Stack.
Yeah. It just pops from that the next time it's gonna do a test.
Why would we need a stack? Why can't we just do the next one next?
Oh, okay.
Okay. Okay.
Because it's harder math without a stack. That's why.
Should we make the stack first?
I don't know. I would.
How would we? Okay, I agree. How do we make the stack?
Just a empty list that has a single tuple going from 0 to the length. Yeah, -1 or whatever.
Okay.
Yeah. And then that's gonna say to test the midpoint of that.
Oh.
And then, so we pop that, test it, add to the stack the children. And then the next time we pop the children, test that center, and
Good
yeah.
point.
And then we just have to make sure we're pushing to the end of it and
Yeah.
popping from the beginning or whatever.
Easy. Okay.
Yeah.
Okay. Mid equals 0 plus stack.
Oh yeah, just extract it. Do like a comma b equals
Yeah.
stack dot pop. Does Python have pop? I think it has a pop, and
I think remove just does it.
yeah, we can probably also do remove of 0.
Yeah.
I
That's,
believe maybe.
Python remove.
Yeah.
Yeah. Removes it from the
Remove the element. Does it not take an index?
right.
Oh,
Deleting.
this website is not helpful. Python remove index. Del. No, we want to actually have it.
Pop.
Please. Pop.
Okay.
Hey, it was pop. All right. So pop takes an index. Remove takes a value.
Yeah.
Kind of makes sense.
Yeah.
Kinda. A
That's
b a plus b over 2, and then that.
Does this work?
I don't know.
We get off by ones.
No, well, it's gonna. I don't know. It depends on
Okay.
where you want to check. I mean, I guess there is only one place that you do check, because if it's odd, you check the exact middle. So 3, 0, plus 2, 4 divided by 2 is 1. So odd works. Even.
Oh, I see.
Do you want to check these two, or?
0 plus 3. Let's check the earlier one.
Check the one on the left.
Yeah. So.
Or maybe
4.
check the one on the left and the one on the right.
I mean, we'll
in
get to
order.
it anyway.
Yeah, I don't know. I don't know
we'll
if
get to it anyway.
I don't know if I trust the code to recursively hit every index.
We'll just make
or
sure.
Not.
We'll just make sure that we will.
That's harder.
As long as we have a loop in there. Right? Yeah. Okay, so 4
It's
is
just hard.
3 plus 0 is 3 divided by 2 is 1. That's fine. Okay.
Yeah. Yeah, as long as we recursively do it on the element we haven't checked, we're good.
Yeah.
And it's proportionate, so it's log.
Yeah.
Log stuff maybe is in the runtime. There will be a log in it somewhere.
Yeah. Okay.
So yeah, this works. Expand outward. For I in range, and you can check at mid plus I and mid minus I to make sure they're the same until they're not. Maybe. Or is that
Wait,
actually
do we want, like, this, like,
in
thing
Python
where
in Python does a for loop, does the I persist past the for loop? So like if we break in the for loop, are we able to get the length that it stopped at?
we can just do it before we break, right?
That's way too smart. I was just gonna say like if s at I is not equal to f s at or mid plus I,
Right.
and then just break and then check what the value of I is.
Ah.
But I don't know if that works. I feel like it does though. A minus I, wait, mid minus I, not A minus I. A is the left bound.
Wait.
Yeah. Oh, I see. Yeah.
Whoa.
That
Okay.
was very flipped.
That was very, yeah.
Uh,
Does this work with range? I think it does.
Yeah. S.
Wait, does this work? I don't know.
I don't know either.
It's not equal to mid plus
1 to
I.
B minus A.
So B minus A is the length.
The length of it.
That's
So you
not
might
what
want to
we
divide
want.
by 2.
No, wait, we want this because it might expand past that.
Yeah.
We just want like the len of S divided by 2 or something.
Oh yeah, right.
Okay.
Although, yeah.
Wait, why doesn't it? Okay.
Break, and then
Oh, we should have.
you should probably.
Shit.
Yeah. We should probably check if you can actually get the value of I after a loop, or
Well,
you can just set it.
Why do we need I?
I want to try it real fast.
Wait, why do we need I?
Because we need the length, right? Oh, look at that. You can access it out of the loop.
Nice. Alright, you'll tell me why we need it when we get there, I guess.
Because we're comparing that to the length of the, right? To the length of PAL of what we found, because we're trying to find the maximum PAL length. Yeah, I is the, or no, 2 times I is the length. 2 times I plus 1? Yeah.
We haven't gotten to it if it's doubled yet.
I know. PAL equal, or len of PAL. If you're gonna make PAL the actual palindrome.
Yeah.
Except we just learned we can shove all of this if statement out of the for loop.
But
yeah.
why would we want to?
So that it doesn't do this test every time it's expanded.
This is only when it breaks.
What?
This only happens when it breaks.
Oh, I see what you're doing.
Okay.
Nice.
Nice.
Is that the right inclusiveness? Or do we want to add one on the right?
Oh, right. Because it...
Yeah.
Yeah, okay. Cool.
Yeah, cool.
Cool.
Actually, no, I think it's mid plus I plus 1. Because mid plus I is the last character we checked.
But it didn't match.
Oh, it didn't match. You're right. Yeah.
Yeah. Okay.
Cool.
Should we? This is not. Okay. Just kidding. It was.
No, yeah, it should be unnotated.
Okay. How?
That's
Wait. Oh no. Before. So we need to do the like doubling up.
What, doubling up?
Like if they're okay, yeah, like if the letters are doubled and shit. So like if we start on
We should have erased this.
1, 2, 3, 4, 5.
Okay.
We start here.
Uh-huh.
Oh, let's say it's this. So
Okay.
the palindrome is the whole thing.
Uh-huh.
Right now, it would do this
Do,
and
do,
that.
do. Oh, and then it would break. We should probably check the out
But
of bounds.
But the problem is, well, no, I'm saying that it wouldn't get the whole palindrome. We should check the out of bounds. That's true. But
Yeah. Oh, that is true. It wouldn't.
we need to be like, whenever we're in the middle, if we see the same thing.
So if
So it needs to cover like this.
so, just if s at mid is equal to s at mid plus 1. Also check that guy.
But what if the F is here and not here? We have to check both, right?
Yeah. This is sad.
Yeah.
This feels unfast.
But then if we do this and we get that, then what if we had this the whole time? We can check if they don't match. Huh?
Yeah.
So we don't break if this is the case.
Whoa.
Except
No. We need to be like messing with the whole math of like that is now offset if we are at the case where like I feel like this whole loop is gonna be different.
wait.
And you don't know until you well, you do know. You know initially.
So if we have like fuck.
Well, it'll only be one of the three cases, right? No, it could be FFF. And then you kind of need to expand from all of them.
Mm-hmm.
From the middle, from the side F's, the middle F, and the other side F.
Should we just like start out by doing that?
Yeah.
Just like
See if it works.
another for loop.
Yeah.
That's so sad.
I know.
How
So just copy paste the whole for loop, but it's the access of S that's going to be different. And
Okay,
then the
I
whole
believe
thing is also going to be inside an if
Why didn't it-
statement. So it's going to be S at mid at I plus 1. But then that whole for loop is going to be inside of an if that checks whether S at mid equals S at mid plus 1. Right?
Why? Wait. What about the -1?
Yeah, you have to copy paste this whole thing again.
Wait, can I just say or? No.
You could if you wanted to make more variables with indexing and stuff. But
Saying so.
yeah. Now is it -1 on the left? I would do my mid minus I minus 1 and mid plus I.
Wait, what is happening?
It's still mid plus I.
Wait, why are we doing this? What is... Why mid plus I?
Because if it's like F, F, A, F, A. If this is where we get, where mid is, we have to test the case where we're checking the palindrome around that point, which involves comparing this to this, and this to this.
Oh, so we're...
And then
So
same for
these
the
are
other
three
side.
different cases.
Yeah, and same for the other side.
Got it.
And I think this is necessary for some reason. I don't remember why. You convinced me of it.
What if we check that and decide it's the center, and then check these?
Do what?
We check that, decide, oh, the center is here, and then we check F versus A.
Isn't that what we're doing?
That's bad.
Why?
Because the palindrome isn't FF, it's AFFFA.
Right, but it'll also check this.
What?
That's this one.
No, but we're not going to get to that because that's something else.
I didn't think you put an else there. Take that out of the
Why?
else.
Oh my god.
You only need to check these. You only need to check this if these are the same. Like, you only have to check this center. Boom, boom, boom. If these are the same.
Wait, I don't want to go through everything twice. Wait, I was just going to combine these.
That sounds hard.
I don't know, it sounds less hard to me. And
But
faster.
how would you combine it? Because if you're at an F and you have an F on either side, you don't know which you should choose as the center.
You look for F's. Look for F's,
Okay.
and then count them, and find and then this is the new end, and this is the new start.
Oh, so first you spread out from the center
Yeah,
by the F's and then see how long the palindrome is.
yeah.
So wherever the thing falls in a sequence of F's, it'll... Yeah, that's better.
Okay.
Significantly better.
Okay. Okay. I don't know.
Yeah.
If
Or... I don't know. Yeah.
S at
Mid plus I.
wait, we do want
We need like we need other upper bounds. And then at the end we'll reassign mid. Why don't you just
interesting.
literally say create an I and a J that are equal to mid, decrease I while mid minus I, or
Yeah.
yeah, just like
Wait.
spin up. So we already have mid pointing here, spin up an I and a J also pointing here, decrease I until it hits the last F, increase J until it hits the last F on the other side,
Right.
and then
Right.
just reassign mid based on those two bounds.
Or we don't even have to.
Or we
reassign
don't
mid.
even have to. Yeah.
Yeah.
Then we just
Can I use
in the
this?
while loop use I and J. Yeah. I have no idea. I would check it. That looks more correct.
Yeah. Okay. Untrue.
While S at I is equal to S at mid. Or while S at I minus 1 is equal to mid, equals to S at mid,
I guess that's slightly faster.
unless it goes out of bounds and breaks everything.
Right. We'll do out of bounds later.
Yeah.
Um,
I minus equals 1.
E.
And same for
Wait, I can do this.
J. Nice. +1 plus equals.
Oh my god. Dude,
What was that?
way too fucking late, man.
Does that work?
Yeah.
Dude, it's 7:30. Oh man.
Oh, yeah,
It's
get it online. I remember. Okay,
well,
well,
like a bulleted list.
okay, now that we have these, okay.
Yeah.
Okay.
Now, for underscore in range of, I guess we don't need I at all.
Yeah, that's true. That's true.
If mid minus S at I. Or actually, can you just do like while S at J, while S at I equals S at J, I minus minus and J plus plus? Yeah. Yeah.
Wow, that's so nice.
That's real nice. Man, imagine if this was not in Python.
Yeah.
This code would look so great. J plus. And then that's great. We did it. We found the maximum
We found
palindrome.
it.
If the if J minus I is bigger than, and I don't know if it's J minus I minus 2 or something. J minus I is less greater. Yeah.
That's nice.
Right. Yeah, maybe. Except it might be I to J plus 1.
Right there.
And it might be I plus 1 to J.
20 off by 1 errors.
I know.
We'll get back to it.
Yeah, we got the idea.
Yeah. Okay.
You haven't.
Stack dot append.
Aye.
True. Stack dot append.
Oh boy. Oh yeah, now we only have to go up to the original I and J. Or
A and B.
Or do we have to go to...
No, we
As
have
far
to
as
do the
I-
entire thing. The only thing we can take out is mid.
That's sad.
Yeah.
Okay.
Really?
Really?
Yeah.
Okay. I believe you.
Yeah, because there might be centers in what we've searched.
Yeah.
It's unlikely, but I'm sure it will happen.
Yeah.
Okay. A plus mid over 2. Okay, what if we have 4? Mid is 1. A is
mid. Yeah, A
is
plus mid over
0.
2 is... Wait,
1,
wait.
0. Oh, that works.
Wait, aren't we supposed to be appending two different things? We're supposed to be
Yeah.
appending A to mid and mid to B.
Oh, true. Wait. Alright.
Yeah.
A to mid.
And then mid to B. And then probably minus 1s and plus 1s. I don't know.
Alright.
Oh, shoot, sorry. I think we made the original A and B inclusive. So we would want A to mid minus 1 and mid plus 1. Or no, yeah,
we
because
made
these
it
are
exclusive.
no, because these are just the ranges of where the mid could be. We already tested at mid, so we don't need to test mid again.
Right.
So it's mid minus 1.
Wait, if I did land minus 1, okay, I think you're right.
Yeah, we tested from mid. So
And then plus 1.
yeah,
Okay.
yeah, that sounds good.
Yeah.
That's probably right. Probably right.
Yeah. And then
Feels palindromic.
return pal. Is that it?
That feels good.
Alright, off by 1s. And shit.
Do we want to ever break and stop appending things when I is equal to J or something? like don't append this if it is a range of length 0 or something. That seems good.
Wait, what?
If mid is not equal to A or something. Yeah.
Is mid not equal to B?
I would think so. This seems decent. You want to go ahead and throw print somewhere?
Probably.
Let's do
Minus 1.
Oh, well. Gray, yes. Gray is less than minus 1. Okay. While both of those conditions, except maybe flipped, while I is greater than or equal to 0, and j is less than or equal to. Or maybe not, I guess that doesn't matter that much. But you should test the last I and j. Yeah, let's say equals.
Okay.
Yeah.
Yeah.
And then that's probably wrong. J plus minus I plus 1.
Okay, if you have 4.
If J and I are inclusive indexes. So
3. That should be right. Right?
no, if I is 0 and J is 1, you want the length to be 2?
Wait. If I is 0 and j is 1,
So like AA.
that's AA?
Mm-hmm.
True.
And then, since I still think J is inclusive, do S at I colon J plus 1. And this feels
Okay.
decently edge case handled, maybe.
Yeah. That's pretty decent.
Yeah.
What do you want me to put in print?
I would print at the beginning, we'll say, or after we create mid. Let's print
Maybe mid?
testing
Or
mid for I comma B or something. For A, B, yeah. And then maybe let's print after 24. We'll just print the maximum expansion it finds. Yeah. So they print expanded test found. I don't know. Expanded, and then we can found, and then we can literally just print S at I to J plus 1.
this?
Yeah.
Oh.
Yeah. Yeah, that seems reasonable.
Okay.
I like it.
Alright.
I'm gonna have such a clue what this code is doing right now.
Hell yeah.
Unless it doesn't run. Wow, that was fast. We forgot -1 on the len. Less than or equal to less. Or we can make it a less than, but that's more confusing.
You're right.
Yeah.
Okay. Run code.
That was a good error, though. Oh, look at that. Testing 2. 404. Expanded test found, but bad. Bad? Oh, bad.
Wait, no,
The
that's
test
not.
found bad?
But bad?
Bad
Found
is not a
bad?
palindrome.
Oh boy.
Oh, it's because, yeah, it was because I and J end after the palindrome. Sometimes. So I think it found A. I don't know. This is awful.
Wait, what?
Because first we increment and decrement I and J, And then the next iteration, s at I, is unequal to s at j, and so it breaks with the indexes
When do we
of
increment them?
in the while loop.
Here?
No, the first one. Or the third one, sorry.
This?
Yeah.
But we shouldn't go in that if it's bad.
It stops when it turns bad. We break out of the while loop after s at I is unequal to s at j.
Oh, okay.
Which is...
So this gets A.
Yeah. So this is the B and that's the D, so...
And this?
Yeah, except for the cases where we're like at the end, like the bad and stuff. I think it depends on which we break. So maybe we could do the test outside, like after or before. But I don't know. Actually, I think what I would do... No, I don't know.
Wait. Actually, this
yeah,
should
this
work,
is
right?
probably nicer.
Except then this breaks.
Yeah, so now we have to make them the same, less than, instead of less than or equal to.
But then we still have the same problem, right? At the end?
I don't know. Try it.
I'm sure we do.
Run it real quick for me.
Okay. I need to put this back.
Yeah. Abba.
Wait, really?
See, that looks a lot better. Now the issue is just it's breaking because of this.
Oh, right.
So I guess we could just throw an additional check at the end to test if at I minus 1
Wait,
equals at j
we
minus
should
1.
just put this inside.
Yeah, that might work too.
Wait. Oh my god. I hate this.
If s at I minus 1 is not equal to s at j plus 1 break? Is that the way to do it? I don't know.
Maybe. That sounds
Actually, yeah.
Yeah?
Shouldn't we be able to make I and j before and after the palindrome and let them run out of bounds? But just like break if they are out of bounds? And then at here we do +1, so even if it's at -1, it does -1 +1.
Mm-hmm.
That seems like that would work.
Mm-hmm.
So, while I is greater than or equal to 0, and j is less than or equal to n minus 1, and s at I equals s at j. And s at I equals s at j. And then in here, it's going to be I plus 1 to j.
Wait, but this still breaks.
Oh, did we already tried this?
Yeah, this was the original.
Really?
Pretty sure. Wait, we didn't change the print.
Bad.
What?
Bad. Yeah, you're right. That was the original.
Wait.
Why would it be fine? Oh. We didn't change the print. Shouldn't this...
But this will still fuck up at the ends, right?
Oh, yeah, because B isn't equal to D. The answer is ABA.
Uh-huh.
Oh, cool. We did it.
Wait, but this will still fuck up at the ends, right?
No. Because it enters into this if the B is equal to the D. And then decreases it and then breaks for this reason. At which point I is before and J is after. Which is why we do +1 to that -1.
Okay. For some reason I thought it broke. But okay. Got it. Convenient.
Lit.
Shall we submit?
Go for it.
Let's see.
That feels
Okay, we got BB.
We got
literally
D.
got BB.
Yeah, wait, hold up. What's our Oh, this needs to change now. Now it's J minus I. Oh my goodness. Wait. Boop, 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 boop. Now it's J minus 1 minus I minus 1. No, minus I plus 1. J minus 1.
Really?
J minus 1 minus I plus 1
So J minus R minus 2?
plus 1. I don't know.
Wait, wasn't this what we had?
I don't remember.
Or was it a +1?
I think it was a +1. Yeah, you're right, because now it's going to be 2 bigger, so we have to subtract 1 instead of add 1.
Got it.
Oh! Wait, that's fast! Wait. Oh, that's very fast!
Holy shit!
That's really fast. That's like linear, right? Maybe?
Oh my god!
Or maybe nlog n? What do you think? You think it's nlog n?
Holy shit!
Oh my god. And that was easier conceptually.
Oh my god!
That was beautiful.
You literally cut it in like 6.
Yeah.
Oh my god.
Okay, what's the runtime though? Like, because I don't think this is linear, but it's good, and I don't know why this isn't a common solution on the internet. The internet's freaking like n cubed, n squared,
Yeah.
dynamic programming, when you could just do this.
Holy shit.
I don't think this is the linear. Should we look up the linear?
Yeah.
Yeah.
Wait, let's look at the YouTube
I'm so
video.
happy that this worked though.
Oh my god. I
That's
cannot
awesome.
believe it.
That's
I
amazing.
cannot.
It's
Holy
so simple.
shit. It's so simple. Oh my god.
It didn't even have weird edge cases.
I know.
Oh,
Oh.
that's satisfying. Wow. That's very satisfying.
What the? Oh my god. I'm in disbelief.
I'm very proud of you, Eli.
Oh, thank
Your method that felt very sketchy
Oh yeah.
was perfect.
Yeah. Oh my god.
That's crazy.
I had
That's
a
even
feeling-
with the prints. Like, we didn't even take out the prints yet.
Yeah.
What the heck?
And we didn't like optimize it or anything.
No? Yeah.
I have a feeling it like legit is N.
Could be.
I can't
Just like for math
prove it.
reasons. Yeah.
Yeah.
It might be 50%. We've got 100 milliseconds faster.
Holy shit.
And we're like messing with a stack and stuff too, which is not
Yeah.
fast. That's crazy. It's so easy.
That. Oh my god. Look how beautiful.
I know.
Oh. Really?
That's crazy.
Damn.
And we're doing the len of pal instead of just storing the indices and stuff.
Uh-huh. Although
Well, that's
as we've
probably
seen,
fast. Yeah.
Doing the line somehow is like
Somehow it's faster.
faster.
Yeah. Wow.
Oh my god.
We got the like off by ones too.
Yeah,
It
we
was
did.
It was just like the one.
Yeah, that's the only thing
Yeah.
we ran into.
I know. I
like,
thought it was gonna
yeah,
be like messing with that stuff
for like an hour.
Yeah. Right.
I cannot believe. Michael, this is the evolution of a programmer. Freshman year of high school, we like hit our heads against the table trying to figure off by one errors.
I know. Now we know
Fucking
them.
easy.
Oh, that's crazy. That just works?
It's just, oh my god.
That's magical. Wow.
Should we like try to optimize it? I feel like there's.
I
What
don't
else
even.
could we do?
I don't know what we would do.
Like
really.
the stack. Like how would we get? Like the stack seems like a good idea. Like now that we're doing.
Yeah.
I feel like.
Unless you think doing the recursive thing and like depth first testing would be faster. I don't really know.
We never even short circuited. I forgot about that.
Yeah, we forgot like one of the main ideas.
Yeah.
Of why we're doing this.
Of like literally why it's going. Yeah.
Yeah. Should we add like a quick test somewhere to be like?
I don't know. That sounds hard.
If
yeah, maybe. I don't know.
if the length is bigger than half or something, or
Yeah.
or if the length is bigger than the window we're in,
Or
if the current length is bigger than the window we're about to test.
not.
Don't
the
test this window.
No, it's.
Oh no,
it's
you're
the
right.
Distance from mid to one of the ends of the actual string.
Right.
Yeah. I mean, I feel like that wouldn't even help much anyway.
Yeah. I mean, it will iterate all the way to the end and stuff. And recurse and stuff. Yeah, and recurse. So, let's try it. We should try it.
Okay. You want to do it?
No, you want to do it.
I want to do it.
I want you to do it.
You want me to do it?
Because it's just going to be, like, a simple case here. If the len of the pal is bigger than b minus mid, nope.
No, it's
Len of stir.
Yeah, len of s.
Len of s minus mid. Or
Wait, there needs to be like divided by 2 somewhere.
oh wait.
Or times 2. Wait,
what does this one say? The len of pal.
yeah, divided by 2. I'm probably gonna get an off by 1.
If the len of the pal divided by 2 is I see. Right? Yeah.
I feel like we're gonna get an off by 1.
Yeah,
Probably.
definitely.
All right, let's see.
Just worked. And it worked fast.
Okay.
What do you think our off by 1 is? If the also check the details. I want to see how far it got. Real quick.
Oh my god, it's literally the last one.
Wow, barely off by 1.
Barely.
So good.
So good.
If the length of the pal over 2 plus 1? I don't know.
Minus 1.
Minus 1?
Yeah, because
Yeah, that's
to be
safer.
less strict.
Yeah, right. Or the... I don't know.
Wait, does it tell us how like fast it's been? I don't know.
No, it doesn't.
Oh, it doesn't?
Annoyingly, no.
Okay. What the heck?
Minus 3. Is it
What?
so if this
what?
is if we're looking at this window, is it because we're like, oh, you can't test this one, but it's blocking it from testing this one?
Wait.
It's blocking it from testing the bigger ones that maybe would fit in it? No, because we're
shouldn't
checking
be,
the
yeah.
length of the pal.
Okay. I'm gonna guess 4, and then I'm gonna guess 20.
Yeah, that sounds real good.
I don't need to look again.
I'm shocked.
I am as well.
So we're outputting like pretty close. 0, 1, 2. It's actually really hard to tell.
Wait, so if len is 100, right?
Mm-hmm.
Divided by 2 is 50. Okay, and mid is 25.
Oh, can
Then it can only
the
be
length
50.
of can the
What?
never mind, I'm confused.
Oh.
If the length of the pal is bigger than I don't know. What if we move this division by 2 over to here? Multiply that by 2.
No. That would be way too generous.
What? No, it's the same thing. If the length of the pal.
Oh, you just multiply by 2 instead?
I just mean this.
Yeah.
Because it should be the same. It's just I think this makes more sense for me.
Yeah.
The length of S
This
minus
is the
the mid
maximum possible
minus the
that
mid.
it could be.
Actually, we're not doing like the
Unless
the distance from
that's
we
the
have
distance from the end.
the length of S. So if mid's over here,
Uh-huh.
it's gonna be this much times 2.
Uh-huh. So that's the maximum palindrome, the maximum possible palindrome we can find.
Yeah.
Is that long?
Or if mid is here. Right, but mid would recursively spawn one here. That might be longer.
You're right.
Yeah.
Oh.
So you have to do it like one-sidedly at the end before we recurse, right?
Oh, wait, 1 second. Yeah.
Or I believe you. Whoa.
Right. Just everything is in this if. It only does this part,
So you don't know.
but
Go for it.
it continues otherwise.
I trust whatever you just did. I didn't really understand. You also have a minus 20.
Oh
my God, we're so good!
Oh my,
We're so smart!
oh my god. Oh my god. Short circuiting actually works.
I know!
Okay.
Minus what? I don't know.
Great. So less than
I don't know.
plus 1?
I don't know.
Minus 1. No, this is plus 1, isn't it? I cannot believe that.
I know.
Alright.
That's near as fuck!
I'm telling you. Holy
Dude,
shit.
I bet that's the algorithm. Like this is
Oh my
this is
God.
good to the point where I think we rediscovered manicures.
Well,
Let's look up manicures.
Yeah.
Yeah.
Let's watch the YouTube.
Oh,
video.
that was sad. So satisfying. 250 milliseconds
Oh my god.
from
we were
9,000.
9,000. Alright, let me see.
What? That's great. That's great.
40.
40 times faster?
40 times fast.
What is the square root of 900 or 500? So oh, it was 2n squared.
Oh?
It was 2n squared, and now it's exactly n.
God.
That's satisfying. Oh, that's very satisfying.
Wait,
Manicure's algorithm.
sure.
Yeah.
Can we watch a YouTube video?
Just go to Wikipedia. I bet it's
Okay.
pretty obvious. It better be pretty obvious because it was obvious to us. Oh. The following characteristics or observations about a palindrome and a subpalindrome.
Okay. Left side of the palindrome is mirror image of the right side. True.
Okay.
Case 1, a third palindrome
whose center is within the right side will have exactly the same length as a second palindrome anchored at the mirror center on the left side.
Okay.
If the second palindrome is within the bounds of the first palindrome by at least one character.
True.
I have no idea what that means.
Okay, so if we have...
Is that what our algorithm did?
I don't think we took advantage of this fact. Long-ass palindrome.
Uh-huh.
This happens to be the center of a different palindrome, right?
Okay.
What that means necessarily is that this is the center of same side.
For the whole thing to be a palindrome, or what? No, a third palindrome whose center is within the
Same length.
a third palindrome. What is the first palindrome it's talking about?
Yeah. What if we have A, B, C, D, E, F, G, H, G, F, E, D, C,
Your algorithm's
B, D, E. Alright, so the center's here. There's another center. Whoa. Oh, because... Wait. So it has to be C... Oh no, they have to be the... Fuck, it has to be C... D... E... Oh, but then this would have to be D, E... Okay. But then this could stop and this could keep going and be F. So this is 7 and this is 5. I don't know why.
I have no idea what this is saying.
D-A-C-A-B-A-C-A-D.
Where's my mouse?
The whole string
is the first palindrome. ACA is the second, and ACA is on the right.
Oh, this is one case. Okay, so that's
Yeah.
not necessarily true. This is one of the cases.
One of the cases for how they expand a palindrome,
Yeah.
I guess.
Yeah.
So
Okay.
they first find this. Why do they first find? Oh, they first find this, and then they use this to search for other palindromes or something.
I don't know. We haven't gone there yet.
Yeah.
I think. Okay. If the second palindrome meets or extends beyond the left bound of the first palindrome, then the distance from the center of the second palindrome to the left bound of the first palindrome is
It's the
exactly
second
equal.
palindrome. So this is the second palindrome. Meets or extends beyond the left bound of the first palindrome.
Wait, it says ACA on the left side is the second palindrome. ACA on the right side is the third palindrome.
Oh, so this is the first palindrome.
Okay.
This is the second palindrome.
Yeah, that's it. Okay, yeah.
If the second palindrome meets or extends beyond the left bound of the first.
Okay. So like this does.
C, D, D, E, E. Yep. Then the distance from the center of the second to the left bound of the first.
To the left bound of.
Why are they doing this?
Holy fuck. To the left bound of the first. Okay. Here. Oh, this doesn't. This extends beyond, which is probably. Okay. We'll just make this palindrome 2. Okay. That distance. Okay. They just. Yes. The second to the left bound of the first palindrome is exactly equal to the distance from the center of the third palindrome to the right bound of the
first palindrome.
That's true. Except I'm switching left and right because I'm fuck. Oh, I won't. Okay, fine.
Wait, what's the deal? So it's saying the distance from the center of the second palindrome, this guy, to left of the first, this to this is the same as this to this?
Yeah. That's just kind of
kind of stupid. Okay.
Yes. To find the length of the third palindrome under case 2,
Under case 2.
the next character after the rightmost character of the first palindrome would then be compared. Okay, hang on. Sorry.
So it's comparing this guy.
Be compared with its mirror character about the center of the third palindrome.
Which is this one? First palindrome. The right outermost of the first is comparing this to this. That's weird.
Right outermost character of the first palindrome.
Oh, first palindrome.
Which is
What?
that.
It's comparing it to itself.
Will then be compared with the mirror character about the center of the third palindrome. So that.
Oh.
Until there is no match or no more characters to compare. Okay. Either the first or second palindrome provides information to help determine the palindromic length of fourth.
Why are they doing it like this?
Centers outside the right. Oh my god. I can't.
I don't know.
Let's go to YouTube.
Okay.
We have to.
Real quick though. Oh!
Can't fuck coded so much shit.
Okay, that's slightly better.
I checked Discord. Send up 5 messages.
I don't know.
What I do. I don't know about you.
You what?
Oh. You do have 5 messages.
Hmm. 23 minutes? 16 minutes? 14 minutes. There we go. 25 minutes?
Oh, that's not.
That was the guy that comes up for.
Let's do it.
Oh. Wow, very downvoted. Maybe let's not.
Okay. Maybe Manicus is just a terrible algorithm.
Well, it kind of sounds like it.
It does. Guys, do mine.
Yeah.
It's so easy.
Oh, there we go. This is the good one.
Alright.
Manishers.
Why would you do this to someone with a heavy accent? Okay, just turn it up.
Yeah.
We have already discussed the dynamic programming based solution for this particular problem, which is order of n square. Please take that video out. For now, we'll go ahead and discuss the most efficient algorithm for this, which is Manish's algorithm. Under the dynamic programming, there is another order of n square algorithm where we expand around the centers to find out the palindrome. Okay, so each character is considered as a center, and the gap between the characters is also considered as a center for even palindrome. So, for example, we start with A, we find out the palindrome length for that, then in between A and B, then find out the palindrome length for that center, and so on. We do that till the end. Once we have all the palindrome lengths, we'll take the maximum of the palindrome length.
That's a way easier n squared.
But this is order of n squared.
What's wrong with us?
What? No, but that's like not as good. There's no way.
That's probably faster than this shit we were doing.
Oh, before?
Yeah.
Yeah. Yeah.
What's wrong with us?
I don't know.
Jesus. That's terrible.
Yeah.
Expanding around the centers. So if we consider A as a center and expand around it, we find a palindrome of only length 1. Okay, one character. If we go ahead and put a center in between A and B, we won't find a palindrome because A and B do not match. Okay, given this as the center. If we go ahead and consider B as the center, we'll find a palindrome of length 3. The next center is the empty space between B and A. Again, the palindrome length is 0 here. If we consider A as the center, we'll find a palindrome of length 5.
So this is what we do, just with the clever ordering.
Now let's take a thinking pause.
Yeah, and he doesn't short circuit.
Right.
Every center is vertical.
Which, yeah, that helped a lot.
Let's assess our progress and see where we are right now. Okay, we have expanded all the centers all the way.
My theory is that the short circuiting is what makes it end.
Yeah.
And B as a center palindrome length 3, A as a center palindrome length 5. Okay, and for the rest of the centers, A, B, A, we don't know the palindrome lengths. Right now, I'm omitting the centers in between the characters just for simplicity. Now let's just concentrate on this center, which is B, second last character, and try to figure out its palindrome length by not expanding. To do that, we'll look at the palindrome center at this point in a different manner. Let's look at it in a different perspective, like this. What we see here is palindromes are symmetric at the center. the right part of the That is the definition of the palindrome, right? So that's just what we are going to use to cut down our expansion. Okay. So you see here, every character on the left hand side is mirrored on the right hand side. Since the characters on the left hand side are mirror images of the right hand side, what we can do is we can directly copy the mirror lens towards the right side. Okay. So what would be the length of the palindrome here? If you look at it without expanding, just look at it. Don't execute an algorithm. Just look at it. You see that at this point the palindrome length is 3, right?
Oh,
What is given at this point? It is also 3.
Sure,
Instead of expanding
even
here,
more if we want.
where we have question mark, instead of expanding here, we'll directly copy the palindrome length from the mirror center to this center. Okay. Let's look for this center, which is the last character. What would be the length of the palindrome here? 1, right? We just copy from the mirror center. Okay. Now for the character A here, what would be the length of the palindrome? 5. We just copied it from the mirror center. Okay. So are we done? Have we considered all the cases? Is reusing the palindrome length at mirror center enough, or do we need more work? Have we reached order of n? These are the questions that come to mind. Right? The answer to all of these is no. Let us assess our progress again. So we have a palindrome center at this point of length 7, which has a boundary here, left boundary, and the right boundary here. Now suppose that this string can be extended from the left as well as from the right. Okay. Let's see where we are at without the extension. Without the extension, we had the palindrome length of 1 at the first character, 3 at the second character, 5, and so on. What if we had one more character after the right boundary? Now let's look at this whole string in a different perspective. The question arises, are the lengths that we copied from the mirror center correct? Are the palindrome lengths correct? I don't think so. Okay? If you add one more character at the right boundary, these lengths change. So if you consider A as the center, the actual palindrome length for A as the center is 3, which is greater than 1. Okay? And if you consider B as the center, it is definitely greater than 3, which is equal to 5. Okay? Now let's take a thinking pause again. The length of the center on the right hand side is greater than or equal to length of mirror. It is not just equal to. It is greater than or equal to. So once you copy the length of the mirror, you have to start expanding from the end of the center. Okay? So basically, once you have 3, you know that the palindrome center at B is at least of length 3. That's why we start comparing from the ends of that particular mirror. Okay? So we just compare B and B, we don't compare A and then we get length of 5. Now let's jump on to the other case where we expand the left boundary instead of the right boundary, and we know what character is after the left boundary. Let's switch this B here. What happens now is the length of the left centers of the main center are greater than they were. So for A here, it expands beyond the left boundary. For B, it also expands beyond the left boundary to length 5. Similarly for the center A. But by first rule, we need to copy this length towards the right side, right? Are these lengths correct? Let's see. Considering A as the center, we see that the palindrome length center at A is 5. So it is at least 5, not 7. Similarly for the palindrome center at B, it is at least 3, not 5. Why is this happening? Because we never know what character would be after the right boundary. We have to expand and look at it. Because palindrome is not symmetric beyond the boundaries. It is only symmetric till the boundaries. That's why the lengths of the palindromes at the right hand side are at least till the end of the boundary. Okay? So how will we get this length? We'll count the number of characters from the right end to the center, including the empty space. So what is the count from the right boundary till the center? It is 1, which is basically the right boundary minus A's index. Okay? Just bear with me for a moment. This is a little tricky. Okay? And now for B, how do we get 3? We count from the right boundary till the B's index, which is basically R minus B's index. And for A, we have another empty space here, right? We count that as well. And A's index, we get R minus A's index equal to 5. Okay? Now this looks very abstruse, right? Now imagine at the center, the palindrome is folded. Okay? A palindrome of length 3 is folded. What you would say is, if you fold at the center, you will get BA. A is placed on top of A here. Okay? If it is folded, you count the empty spaces as well. It will give you the length of the
Yeah, this is too complicated.
Yeah.
Do you care?
No.
Alright, close this.
Alright.
Yeah, that's stupid. This is cool. This is dope.
How?
95%. I'm saying that's the same as manicures, but better because way simpler.
True.
Yeah, it's kind of weird. We have a +1 here and we don't have a +1 over here. But you know.
Yeah, that is kind of weird.
Yeah, cool. All right. Next problem. 95%.
Yeah, that was great.
That's kind of surprising. No, maybe not. A bunch of people are probably content with n squared. I don't know.
Yeah. Okay.
We have a string. Zigzag pattern string. This is medium. Palishing. Palishing. And read line by line. Pahin. Appleseig. Year. That's what it wants. It wants us to zigzag it with a number of rows.
Is that it? Oh, with number of...
The given depth thing. This feels a lot like just math.
Yeah. Seems like
What
really easy.
What is this? PIN P 1 2 3 4 5 I 1 2 3 4 5 N. All right. First you do 5 and then starting up the second one you do A 1 2 3 L 1x. Oh no.
So it goes down number of rows minus 1,
Yeah.
then back up number of rows minus 1. And then yeah. And then same for this, it goes down number 2 and then up 2. Then down 1, up 1.
Uh-huh.
So it's probably mod
Wait, but how are you getting that from the original one?
from the original one?
Yeah.
What do you mean?
Or are you not are you not producing the output in order? Are you just like actually constructing the
Oh, I'm just thinking. So like the first row would be mod 2
plus
num
equals
rows minus 2, and then minus 1. Right? So wait, okay, we get, see what indices we get for row 1. We have 0, 5, right?
Uh-huh.
0, 5, 10.
1, 2, 3, 4, 5. No, 0, 6. Wait, sorry.
It's index 6.
0, 1, 2, 3, 4, 5, 6.
Oh, okay. Then 12.
7, 8, 9, 10, 11, 12. Yep. 0, 6, 12. And then next we have 1, 5, 7.
Oh, because it goes back down.
Yeah.
Oof.
8,
Alternates.
9, 10, 11, 13. This is like the what's that interview question where it's like write the numbers from 0 to 100, but if it's mod 3 you write something, and if it's mod 5 you write something.
Yeah.
It's like that but for each row.
Yeah.
And then what's the third one? Y 0, 1, 2, 4, 8, 10. And then the last one is the P and the I. 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9. Yeah. Yeah, that's slightly annoying, I guess.
Yeah. So this one is mod 6. Then this one is mod 4 plus 1. Then mod.
Where's the other whiteboard back here?
It should be on the ground.
Yep.
Mod 2 plus 1. So this is 4 times 2 minus 2. This is or
What's the easiest way to do this?
4 minus 1 times 2. And this is 4 minus 2 times 2. And this is 4 minus 4 minus 2. No. Why 4 minus 1?
I mean, we should probably not do it with any data structures.
Right.
But it's like annoying. Actually, it's probably easiest to write it out like. Actually, let's erase all of this. It's so funny that we overcomplicated the n-squared solution.
Yeah.
Alright, I'm gonna do it with like a lot of rows and a lot of characters. 0, 1, 2, 3, 4, 5, 6.
Okay, so there's
Why is this?
a boolean that changes. That's up, like up and down.
This marker's not good.
Up, row
0, 1, 2, 3, 4, 5,
0.
7,
It's
8,
always
9, 10, 11,
2
12,
times row minus 1. Always. Oh, this is down, down, down. Oh, and this only has down. And then up.
Yeah, so it's gonna be these three that have like, these are always just the same offset but plus I or whatever. And then there's gonna be at most one more in the middle. That's, yeah. Right? That's seems pretty easy.
Mm-hmm.
So for I in num rows, that's where we start. Or out is an empty string.
I feel like I hear more sounds in this room than like anywhere else.
Yeah. You plus equal did the output.
Of course.
Alright. So first one's easy. It's just for j equals 0, or for j in range.
Is this n squared?
Actually, maybe we should walk through this. We'll walk through this and just when j exceeds the actual length of the string.
I don't think we want to go row by row because that's n squared.
What do you mean?
Oh wait.
No.
Yeah.
It's just
no.
element.
Oh, so we're not actually
right.
Okay.
Yeah.
So
j equals 0, while j is less than the len of stir, len of s, j plus equals, and now I don't know if it's easier to do these inner guys or just, well, we have to hit these inner ones. I mean, should we just hard code the inner ones? Or like hard code the addition?
what
No, we're for each of them we print 2. Yeah. So while j is less than, and j is going to be going this way, right? J is going to be plus equals 10. I is going to be going down the rows. Every time we're in here, we'll output these 2.
Oh shit.
Sounds good? Sounds good. Goodness.
Well,
Alright. J, okay. Let's not increment J yet. And it's gonna be, yeah, J plus equals 2 times the number of rows, is that right?
yeah.
Cool. Times 2. Okay. So out plus equals S at J plus I. Yep. S at J plus I.
Well, it's
If we're
S at
here.
J and S at J plus I.
If we're here, we want to output 12 into 18. So first we want to do
Wait, I thought we want to do
J is 10.
12 and 8.
J is 10. No, I'm going to do it here. When we're here, we output just here. When we're here, we output 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5, 10 and nothing, 11, 19, 12, 18, 13, 17. We can do it either way you want.
Okay, that's fine.
Yeah. So I would start with the 12, which is at J plus I. And then the next one is going to be, how do we get that number?
But we have to exclude the top and bottom, right?
Yeah.
Yeah.
Yeah. Otherwise, we're going to just double count it. But that's okay.
J mod
Yeah. If J plus I mod J or mod num rows. Yeah.
num rows
Times 2. Mod num rows times 2. Do you not need parentheses around the? Is mod the same is mod a higher precedence than multiplication?
I think it's the same.
Then it should be num rows times 2.
You're right.
Okay. And
For the bottom row?
actually, hey, look at that. Mod num rows. I'll take it.
Alright.
Thank you, math. Okay.
Now we can do a times 2. Because 0 times 2 is 0.
Oh, yeah. It's a good point. Good point.
Okay.
If it is not 0, we also output S at J plus I all times 2. No, sorry. J plus J plus len of S times 2.
What is
Plus I.
len of S? You mean num rows?
Oh, sorry. Yes, I do mean num rows.
Okay, like, wait a second.
Yeah.
Num rows times 2.
So we're at 10. We brought ourselves to 20. Let's add I.
Wait.
So
okay,
we're trying to output the 18 right now. So we have
Plus
J
I.
plus num rows times 2 plus I minus
Wait.
minus I
Shouldn't
times
we start
2
at 15 and go...
minus I times 2.
Does that work?
Oh, 21 minus
Wow.
2, 22 minus 4, 23 minus 6. Yeah, minus I times 2. You can probably simplify this math, but I don't know.
Plus I minus I times 2.
Oh, look at that. J plus num rows times 2. Oh yeah, minus I.
Oh, yeah. There you go.
Pretty easy. Okay.
Cool.
Is that it? It feels good. While J is less than len of S, output as much as we can. Maybe let's break out of anything if we ever, like, does this if need to also check that J plus num rows times 2 minus I isn't out of bounds? Or does it not?
Yeah, it needs to check that. If the 28 doesn't exist?
Yeah. Right, yeah. 21 would try to output 29, but it can't.
Yeah.
Yeah, so...
Okay, so this will just be... And...
Yep. Less than the len of the S we have. And then... That seems good.
Well, if J is less than S, so we need to kill that here.
Yeah.
If J plus I is greater than or equal to len of S.
Oh, right, it could end on the 20.
Break? Yeah.
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 Okay. Yeah, it could len on the
Yeah.
20. Yeah. Okay.
Alright.
Do you think this works?
That seems pretty good. That
Seems
seems pretty good.
good.
Oh, what did we miss?
Pinal
Wow.
Yar.
Not very close. Alright,
Okay.
what did we do? So, this is a length of 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 12, 13, 14, 15, 16-ish. That's probably enough. So,
Oh, numbers here is 6, not 5.
oh, we have to minus 1 everything?
Yeah.
Whoops.
Oof.
Number is minus equals 1. Just at the beginning.
Wait. Does that work?
And then add 1 in the I loop. I don't know. It's kind of sketchy, but I feel like we were definitely using numbers of I, or numbers as 5 for this whole 6.
Uh-huh. Feels so bad. Okay.
It feels kind of bad, but also like kind of good.
Yeah. You're so wrong. Well, what do you know?
Look at that. I like it.
Incredible. Integer division or modulo by 0.
Wow.
Num rows. Did you give me 0 for num rows?
Did they give us 0? It doesn't say.
It says 1?
Oh, I guess 1 is the... Yeah, they gave us 1.
Oh, I minus equal 1.
If 1, return S.
Yeah.
If numRose is 0... Or I guess just do this on the line above, so it doesn't waste time subtracting 1.
Waste goddamn time.
Or creating a string.
Here, we don't even fucking
That's
need...
real wasteful.
Super wasteful. Or do you think comparing with 1 is super...
Nope, I don't. Wow, that's pretty slow, though.
It is pretty slow.
Why is it pretty slow? Just too much math that we didn't simplify?
Maybe.
Probably.
Why is it slow? We went through it once.
Yeah, we went through every element once. It's probably just a lot of, like, if checks.
Yeah, maybe.
We're checking the bounds probably more than we have to, maybe. I don't know. Do we care to fix it?
I mean, it's the right solution, right?
Yeah.
The only question is just like minor optimizations.
You think flipping I and J is gonna be Oh, also we could probably put the J in a range loop or whatever. Instead of
Where? Oh. Instead
you
of
mean I?
every time. J in a range loop?
And a 4J in range. Because I think you can give a step in the range function.
Whoa, you're right. Okay.
I don't really remember the syntax for that. range from starting at 0, going up to len of s minus I. Yeah.
Is there a 1?
Stepping with numerous times 2.
Do you think we're missing a 1 here?
No. This seems good. Wow. We just guessed the syntax of range. Yeah, 67. There we go.
That's better.
8 milliseconds better.
Yeah.
I don't know how this could be faster.
I got it.
You got it?
Watch.
Alright.
Do you think that's faster?
Wait, does that even work? I thought sometimes we had to be appending twice. Outputting twice. I don't know what you're doing.
Okay.
Yeah, that seems better.
Yeah. Alright.
I mean, we did the math they wanted us to do. Seems pretty good.
Yeah.
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 Onward. I don't
Alright.
care that much about
I mean,
this problem.
yeah.
This problem's just not very exciting.
Yeah. Oh, look at that.
We get a hard. Oh, thank goodness! An easy. I can sit down.
Reverse.
Given a 32-bit signed integer, is that even a thing in Python? Can it even hold a 32-bit signed integer? I thought all of Python's stuff was variable length.
Huh.
Maybe not.
But,
Assume we're dealing with an environment that could only store integers within that range. Reverse digits of an integer. Ha! 6,000 downvotes. 3.8 thousand upvotes.
Oh my god.
So this is a stupid question, I guess.
Yeah. Oh wait, but we have to...
I almost want to just turn it into a string.
Oh yeah, it could be.
We could also do it in a loop, but we have to output as we loop, right? We have to do this repeatedly. Do it with math.
Well, I'm doing recursion.
Oh. Wait, that's great. I love it. Return
Wait, you can't get
10
this.
times. No, it'll just keep adding 10. 10 to the power of the length of the number? Length of the number? What's len of 8?
Len of 8 is 1.
Oh, really?
We need a base case.
In Python, the length of a number is the number of digits in it.
Wait, I feel like
Yeah, but now
converting it
it's
to stir is like the wrong
Bad.
thing.
Yeah, it's like bad though.
I mean, how else could we get it though?
Every time you multiply the previous number that you had by 10 and then add this last digit.
Multiply.
So yeah, so first you pick out a 3.
Uh-huh.
Next recursive iteration, it multiplies that 3 that we give it by 10 and adds the 2. So let's add another argument that is like on or something. I don't know. On is probably bad, or maybe out. Out is initially 0. out is initially 0, and then we're gonna pop the mod 10 into the out,
Mm-hmm.
and then inside out is gonna multiply out by 10 plus. Oh, so maybe it should start at 1. We're gonna get edge cased to hell, like, because of like this shit. Which is probably why it has a billion downvotes.
Nah, this seems fine. Wait, so did put in divided by? We pull out the 3.
So I'd say
We should pull out the 1. No, the 3. Yeah, the 3. And then out is 3, or is it?
Okay, so x. Okay, you calling? Yeah, you call it with the 12. X mod 10. Yeah, that seems right. Return. Yeah.
So this should be 0.
Yeah. Right.
Okay.
Out times 10 plus x mod 10. So initially it calls it with 1, 2, and a 3. If x is 0, return out.
Oh yeah, because it divides.
Yeah. So first it calls.
Wait, 8 divided by 10 is 0. Yeah. Okay.
First it calls 12, comma 3. Right?
Mm-hmm.
And then it calls 1, comma 32. And then it calls 0, comma 321, and then it returns 321. I like it. It's classy.
Classy.
It's a
as
classy
hell.
way to do it.
I have a feeling the time's going to be bad because most people are just going to make it a string, reverse it, and then make it back into an int.
Reverse is undefined. Excuse me.
Hello?
Self dot. Is that it?
Oh yeah, because it's.
Oh, because we're in a class.
That's self. If this said CLS, it would be solution dot, but or CLS dot.
Gotcha. Time limit exceeded for negative 123.
Excuse me?
I don't want to handle negatives, Eli.
What is negative 123 mod 10?
I don't know. Wait, open up the Python. Oh, move it over.
It's 7.
It's 7?
It's 7.
Okay, hear me out. If we ever have a negative number,
flag.
if we ever have a negative number, make it positive and make the output negative. Right?
True.
Or is does that break addition? That might break addition.
Let's just have a flag for negative.
Actually, yeah, wait. So return. So just right here say if x is less than 0, return negative self dot reverse. Yeah, self dot reverse of negative x divided by 10. Negative x4 divided by 10. Oh, or I see what you're doing. But yeah, either way. Yeah, I like it.
Okay, alright.
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 Wow, that's weird.
9,
That looks
6,
super right
4,
to me.
6, 3,
Expected 0?
4,
Excuse
3,
me?
5, 1. I think.
Is it? I think it's because Python doesn't do 32-bit. What's the deal?
What's the deal?
Wait, look at it. Just said return 0. Wait, for the purpose of this problem, assume your function returns 0 when it overflows. All right, add a case that
what
says
the fuck?
So in that return out, say return 0 if out is less than or bigger than out is less than negative 2 to the power of do we have to 31 or bigger than 2 to the 31 minus 1.
That's
Else,
so dumb.
yeah, that's real dumb.
Why?
I don't know.
Just why?
Oh, look at that. We're
Wow.
fucking amazing.
We're lightning. Damn.
Wait, that wasn't that bad. I mean, that was stupid. It just
Yeah.
wasn't that bad. Maybe it's
Right.
worse in other languages. I don't know.
Maybe. Yeah, that's okay. I mean,
Yeah.
it was easy. It's fine. It's easy. I
Yeah,
guess.
right.
All right.
I like it.
Medium. Okay.
Is A2I a string to an integer? Yes.
Yeah.
The function discards as many white space as necessary. What's that vote for this? Wow, that's way worse. The last one was bad.
Oh my god.
So this is truly edge case garbage.
Yeah, I assume so.
Oh,
Oh look,
Jesus.
still same constraint of
Oh, Jesus. What is this? That's the number. That's not the number.
Okay.
Sorry? The number that is out
Int
of
min.
range.
That's what
Therefore, int
returned.
min is returned. Alright,
Okay.
alright.
Okay.
We can just do the cases.
Yeah.
First, discard as many white space characters as necessary. S equals s dot trim. Or is it only?
Is this gonna discard too many?
Is it only just? Does it only say discard at the beginning or not?
I believe so.
Only at the beginning.
Yeah. So if you find like 42 space, I think you're supposed to kill it.
No, because it says 4193 space with words is the number. So
You're
probably we
right.
can trim.
But if it's 49 space, is the next character is not?
Actually,
Oh, so we can't trim because if it's like 49 space 93, it'll contract it to 4993. But
Really? No way.
Wait, what is trim?
It strips from both ends.
Oh, okay. Got it.
Actually, I don't know. Google it. Python string trim. Strip returns. Oh, sorry, strip, not trim. Strip.
Strip.
Might be trim in JavaScript. We could do else strip if we needed to, but I don't think we need to. I think we can strip both sides. S equals S dot
Oh,
strip.
but that's faster, right?
Whoa.
No.
Still have a while.
Or is it S dot?
S dot strip.
Fuck.
So,
No.
Trim.
And,
Wait, no, yeah, strip. Okay. Yeah, cool.
Okay.
Alright, then what? Then starting from this character takes an optional initial plus or minus, followed by as many numerical digits as possible, and interprets them as a numerical value. It can contain additional characters after those that form the integral number, which are ignored. If the first sequence is not a valid integral, or if no such sequence exists, no conversion is performed. Okay, so regex finding a number at the beginning or what?
Maybe.
I don't really want to like do it myself, even though it would be faster. Probably we should do it ourselves.
Yeah.
So the first one is an optional plus or minus.
Yeah. If S at 0.
There's a plus or minus. Plus or
I guess or, yeah.
yeah.
Wait, are we supposed to convert it ourselves or are we supposed to use the A to I?
No, we're implementing A2I.
Okay, so we want to take this off.
Why?
Why? Because when we start converting it, we want it.
We can take it off after we collect whether it has a plus or minus.
But why?
Wait. The only thing we care about is if it's negative, right? Then we should
Right.
output a negative. So let's just save a negative. Like, neg is
Here
s
should be
at 0.
Equals 1, and then we can make it -1 if it's negative.
Okay.
Wait.
Yeah, because multiplying by 10 and adding still works. To add another digit. Your browser encountered an error. Our browser is mediocre.
I guess.
Thank you, Chrome. Alright. Num equals... Yeah.
Wait.
Num times equals -1.
This should be 0?
I really want to just do the negative at the very end.
Yeah. Yeah.
Just to save whether it's... Yeah. Whoa. You have a molt.
That's whether it's negative.
Okay.
Okay.
If s at 0 is a minus sign, molt is -1. I feel like we didn't need to do it like this, but this works. If that's a minus or a plus, strip it entirely. S equals s at 1 colon. Beautiful. Alright. Now, while true, read a digit. While
s at 0 equals?
while s at 0 equals a digit. Yeah. Well, Ari dot, I don't know how to. I normally do like Ari matches, I think, or Ari dot match. I don't know.
Search gives you match.
Result equals prog dot match. Pattern string. Result equals Ari dot match. Pattern comma string. That works, I think.
Oh, it is?
Yeah. Yeah.
What does it return?
I don't know.
Alright.
But we could just do while D is the Ari dot match. \D.
Is that digit?
Yeah. I don't know how to do non-global. Do you think dot match makes the entire string? Oh, that works. Yeah.
Wait, do you know what this returns?
No, but I'm pretty sure we can use D. I think D is gonna be the matched thing.
We can do find all. I don't know.
No, find all is gonna not do it the way we want.
That's not a character. Oh my god.
Dot group 0. Dot group.
Dot search dot group?
No, this
That would
is
be
the only
dot
one.
group.
Result. What? Stop saying result. I want to see what. Match. Returns. Doesn't say returns.
Match object.
Return a corresponding match object. What is it? How do I get it? Match dot group 0.
What the fuck?
Dot group is the first capture group.
What? don't think we want. Wait,
We want dot group at 0. That's what we want.
I don't think we want match.
Why?
I'm
No,
just
because
gonna-
match matches just the first bit in the string. So, a word space a word got just this bit.
Okay.
Dot group. Although I guess you were doing at 0, so it doesn't matter that much.
Right.
But d dot group at 0 is going to give us the digit we just read, and then we don't even have to just call it on the string.
Oh.
Python.
Okay.
Stir dot is digit. Char dot is digit. That's a thing. Well, that works. Yeah.
Okay.
All right. For char in S. For char in S. For char in S.
Okay.
Okay, fine. You can wow. Wow. That's 0 dot is digit.
Wait, is it?
I don't remember.
Okay.
No, it's lowercase.
Okay.
Thank you, Python.
Nice consistency.
Yes. Integer at S at 0.
Wait. Okay. Anyway. Num equals num times 10 plus s at 0 minus 48. Can
Yeah.
we do that?
Oh, I see what you did there. I don't know if we can do that in Python. Open up the Python shell thing. It's probably gonna be like, that's a character's actually a string, and you can't subtract a string from it. Put it on this screen.
Okay. Why did it do that? Okay. That's not 0.
Almost 0. Whoa. The struggle. Stirring it. What about I at 0 minus 48?
I add 0?
Still a stir, yeah. It doesn't. I don't think Python even has chars. What?
It just made the 0 0.
Oh,
It
yeah,
just
yeah,
is
yeah.
A to I.
Good, good. Alright. Maybe we
What?
should actually just have like a counter that gets the substring that is filled with digits. And then we call int of that substring.
Yeah, but we're not supposed to be. We're supposed to be doing that. We're supposed to be making that. We're not supposed to
No, but that's stupid.
make someone else's. No. Python
Oh yeah, Python
char to
char code. Get char code. Yeah. Ord.
ord.
Ord of where's the mouse go?
Wait. Okay.
Aha. Bring it. Ord of string 1. Nice.
All right. Oh, I should.
Yeah,
All right.
Nice. Ord of S at 0. Beautiful.
Beautiful.
Maybe not slow. Probably
Maybe
slow.
not slow,
Pretty slow,
probably.
probably. Alright, return mult times num. Yep, that sounds right. I think that's good. String index out of range. The S at 0 is S is empty. Why is S empty? Wait, what? Why is S empty? But it
might
didn't
start with
break.
empty.
But it didn't break for this stuff? Oh, they probably passed us just a minus or a plus. No, they passed us 42.
Well, we also never break.
Oh. I see.
Oh, and we should
If none of s or if
holy shit, if
return 0.
and then this returns 0 if there's any
Yeah, probably.
things anyway.
Mm.
Yeah. I think so. Yeah. Oh yeah.
Oh,
we need a
yeah,
fucking
Boy. It's such a dumb requirement because it's like either we have to hard code their special
Yeah.
case, or the programming language would handle it normally.
Right.
Like,
Right.
uh,
Okay. If. Okay.
or maybe it wouldn't. I don't remember.
Less than 2.
To the 31 minus. Wait, no. Negative. Yeah.
I don't know how this works. Oh.
No, I think power is higher precedence than minus.
Oh yeah. You're right.
I think you did that before in the last one.
I think so.
Do them in separate cases though.
Yeah.
Negative 2 to the 31. Is there a clamp function in Python?
What is that?
Like it would clamp a number within a given range. If it's bigger than the upper bound, it clamps it to the upper.
Ooh.
Search for Python clamp. I just wanted to see if it exists.
Okay. I'm just gonna. Okay.
Clamp integer to some range. That's not a. Wait, scroll down a bit more. Sorted? No. No. What is wrong with people? NumPy has it. NumPy.clip. No, NumPy doesn't really have it though. No, and NumPy.clip. It does have it. All the other ones are stupid.
Okay.
But we don't really. No. Yeah.
Yeah.
This is acceptable.
Yeah. What do you mean?
They gave us a space.
What do you? Oh. God damn. Oh, that's the first time I did it tonight.
Yeah. The frequency's decreasing. Oh, look at that. We did
Yeah.
it. Okay,
Wow,
next
incredible.
round. That was stupid. Ah, more upvotes than downvotes. Determine whether an integer is a palindrome. Wow.
Wow.
But this is way easier.
Yeah. Wait. Okay. If.
Actually,
none of
can we
X is less than or equal to 1, return true. True. What?
Whoa, what? Stop checking the length of an integer.
If apps of X is less than 100.
I want to make this one recursive too. Can we make this one recursive?
Hell yeah, I am.
Good.
Turn
Return x mod 10 equals equals.
Uh-oh.
Uh-oh. Uh-oh.
Uh-oh.
That's unfortunate.
Should we do another one?
Should we pass down a freaking stack or queue or whatever? No.
No. Oh, also it's negative 121. It's not a palindrome, apparently.
Oh. I don't know about that. We can't really do it recursively, can we?
Maybe not.
Is
But I
there
really want to.
is there a built-in function that gives you the like order of magnitude of a integer? Or like how many digits an integer is? I feel like that would be a built-in function,
Maybe.
but maybe not.
I also feel like it kind of defeats the purpose again.
Is a palindrome without converting it to a string.
Interesting theory.
Hear me out though. If stir of x equals reversed stir of x. I bet that's
Wait.
even fast. I kind of want to see
Do
how
you think
fast
we
that
should
is.
like?
What? No, why?
Is that valid?
String to integer? We have an integer.
Oh, we need the other way around.
Yeah.
Well, should we just make it?
Can you real quick test how fast using the built-in string conversion is?
Yeah.
Return stir of x is the reversed of
How do you
really? Yeah.
Is there?
Nope, just reversed of. Whoa. Parentheses instead of. Yeah. Actually, that might not be a function. It might be at : -1. Yeah, stir at : -1. I don't trust this reversed thing. I don't know where I got that. It's kind of weird. Yeah.
That's not even that fast.
That's not even not that fast.
Yeah.
What is this?
I'm making the function.
Why?
Because what else would this problem be then? It's not just that.
Are you sure?
Unless it wants us to do it with like actual math
Math?
instead of converting it to a string and then doing this.
Is there math to figure out if something's a palindrome?
Or like if we store them in a list and then pop them,
Really?
a stack and pop them, but then we can't do that
Why not?
because we don't know
No, the
when we
length of
start
the
popping.
integer?
Yeah. I mean, we would have to. We could find the length of the integer first, then it could be recursive.
Yeah.
So what do we want to do?
Kinda am content with the stir of x is the stir of x reversed, but
Yeah.
I would be okay if you wanted to do something a little more interview response-ish.
Yeah. Let's do it.
But not this way. I would what I would do is get the length of the integer
Right. Same.
and then recursive because it's classy.
Right.
Yeah, let's do that. Actually, how do you strip off the
Wait, this isn't.
How do you strip off the greatest digit mathematically?
You would subtract 10 to the power of the length
Times
ish.
the digit there?
Yeah.
That's ass.
Yeah.
Alright, let's do it.
True.
This is gonna be slower. I can see it, I can smell it.
Yeah, maybe. Okay. Len equals 0.
While x divided by 10 is positive?
Well, we need to keep it. Right.
While x is not equal to x mod 10? Is that
What?
more to your taste? Divide by 10?
What?
No. While x is not equal to x mod 10, x divided equals 10.
Oh,
Is that what you like? I don't know.
this isn't what we want. Wait.
We just want to count the length. What do you mean?
But x is like never equal to this.
It is once you've divided it all but the last digit.
Not equal to. Oh. Also, that's not.
Oh
Wow.
yeah. Wait, can you not do not equals, exclamation mark equals in Python?
I don't think so. You need to open over here, okay? I don't.
Yeah. 3. Nice.
All right. Okay. Okay.
Also do special handling for negative. If it's negative,
I did.
you did. Nice.
Okay. Now, return.
Is this gonna get kind of ugly because of like 1-1 is a palindrome?
No.
Yay!
Oh my goodness.
Oh right, because we're gonna wait. So if we have 181, we want to recursively check whether 8 is a palindrome, right?
Uh-huh.
But if we have 1-1, what do we want to check if it's a palindrome?
So, and then,
Special case.
wait, what would we...
Do you just want to say if it's less than 100? Check if
that would get 0. We subtract 1 and then we subtract 10.
right, which is. Oh yeah. Look at that.
Look at that. Alright, cool.
Good.
Convenient. Okay, how do we get that digit? Oh, we divided by
So
y
you want
divided by...
do you want to save the left digit somewhere?
Yeah. Left equals...
Also, can you switch the while loop to
What the
operate
fuck?
on y instead of x?
Yeah. That makes more sense.
Yeah. Also, does len start at 1?
No? Wait.
First it starts at 12. 12 is not equal to 2. Divides by 2. Then 1 is equal to 1.
Yeah, so it does start at 1, right?
Yep.
Okay. And is len
Does this also
correct?
infinite loop if it's 0? 0 is not equal to... Nope, it doesn't.
Okay, this is len minus 1, right? So if the len is 2, then we want to raise to the power of 1 because it's 10. So like 12, the len is 2 minus 1 is 1. 10 to the power of 1 is 10. 12 divided by 10 is 1.
I believe it.
Alright. Left and self dot is palindrome x minus x mod 10 minus
All mod 10? Or all floor divided by 10?
wait, what? All four?
All floor divided by 10? Oh wait, what are you doing?
The new
Wait,
X.
subtract off this guy, and then 4 divide the whole thing by 10.
subtract off.
Subtract off this one to get 81, and then floor divided by 10.
Ooh, nice. Okay, x minus alright, what is that guy? Left times
10 to the,
10 to the power
len
of
minus 1? Is that what it's?
len minus 1, I believe so.
Yeah.
So 3.
Also,
10.
No, actually,
So
that
10
should
to
be
the
right.
2 is 100. Yeah.
Something like that.
Okay.
All
and then-
divided by 10. 10. Binary.
Easy.
Easy. Oh wow. Went all the way to submit.
How?
We said true?
What?
That's not good. How do we
Do you
do
think
that?
it breaks for zeros?
Yeah, maybe. But like, it shouldn't, right? Print after the while loop the len, and then some other things that we're checking and computing.
Oh shit! Yeah, it does. Wait. We subtract this.
Oh no! Oh no!
Oh no! I don't think we can do this mathematically.
Well, that's really sad.
It is really
You
sad.
can't do this mathematically. Unless you add another variable that says at or whatever.
We changed the 0 to a 1 and add a 1 of
Or no, like shove in a number that says deepness or something. Or actually, can we make two parameters, one with len and one with depth?
Okay.
First, if the len is none, we compute the len and call it with the right len.
Okay.
And then we have the len and the depth, and then we can recursive with that.
But how do we know where this? Oh wait. All right. Tell me what's in there.
Oh god, no. Len is none. No one. And then depth equals 0, I guess. I don't know what depth is going to represent. Should depth represent either from the outside or from the inside? It doesn't matter that much, I guess.
Okay.
Probably outside? Yeah, from the outside.
Okay.
Alright, so
Should this all be in an if statement? If len is not known?
I don't know. I kind of feel like we might be ripping out most of this though. Wait. Yeah, you're right. Yeah, exactly.
Okay.
So if len is known, is it not equals not?
Nope.
Cool.
Yeah.
And then do all this and then return is palindrome, like in that if statement.
This one?
Yeah. Return is palindrome x comma the actual len. X comma len comma depth.
Okay. Okay.
Or even without depth. We don't even need to call it there. But yeah.
I feel like it's right.
Alright. And then now we know the length and the depth. And so we should be able to compare. I don't know what depth should represent. I want to say like first you should compare the 1 and the 1 and then the 0 and the 2, but I don't know if that's right. Maybe we should compare the oh yeah, I don't know. Probably.
Seems right.
Yeah,
Okay.
let's do it. So extract the number that is at depth most significant, which you can access via len. So yeah, left equals. Actually, that might be right, except for instead of len minus 1, it's probably len minus depth. And then maybe we should start depth at 1.
Oh, are we
should
never
depth minus 1.
changing x? Got it.
Yeah, we're never changing x. Yeah.
Ah.
Can't update Chrome.
I know, it's been there for like a year now.
Chrome.
Like, literally, I've uninstalled Chrome. And, like, Chrome is still installed. It's, like, literally running.
What the heck?
And after I've uninstalled it, deleted the full... It doesn't make sense.
That's weird.
Depth minus 1?
Len
Wait.
minus depth. Maybe minus 1. minus. That seems right. Maybe. I don't know if that's right or not.
Yeah, I think it's right.
Do we need? Oh, now we have to all mod this whole thing by 10.
This?
Just mod the whole thing by 10 instead of doing it in the return. The entire left. Parentheses around the x divided by, and then mod 10.
How?
What?
How? What? Why?
Just cause. So that we don't have to do it in the return.
Mod 10?
Uh-huh.
We never do left mod 10.
Oh, we should.
Why?
Because if left is extracting the 3 that's there, we should not
now
extract.
we should.
Yeah, now we should. But yeah. I considered it last time, but we didn't need to last time.
Got it. Okay.
And then just say right equals whatever the heck.
Equals
X mod X. It's the same thing, I guess. X divided by 10 to the power of just depth.
Really?
So if depth is 0, it does. Yeah. And then all mod 10. Look at that.
Really?
Look at that.
What? Wait. Okay, let's get the 2. All right.
Let's get the 2. So depth is 1.
Okay.
So.
Oh shit! You're right.
Yeah, look at that.
Damn.
And then return left equals right. And self dot is palindrome of x comma len comma depth plus 1. And then special case, if depth times 2 is bigger than len, we return true.
If depth times 2 is greater than len.
And then also now rip out the line 6 base case. If x is less than 10, return true, just rip that out. Alright, so if depth times 2 is greater than len, so if we just checked that 0 is equal to 0, then we're going to be doing 0, 1, 2, 3, 4. 4 times 2 is bigger than len. Yeah, I don't know. Seems good.
Yes.
Damn.
Int and none.
Oh no. Toss this whole no. Toss this whole if after the first base case. And yeah. Nice. Second time. 9%. Let's go.
Oh my.
Don't do it with math.
Don't do it with math, guys.
Or recursion. We're probably spinning up a lot of call stacks.
Hell yeah.
I like it though. It's perfect.
Yes, indeed.
It's in the spirit of the problem.
Yeah. So good.
Was that a what? I don't remember what the hate like ratio. People thought it was all right.
Yeah.
Which is weird. Is there like a standard way to do this? That would be like stacks or something? Without. It's probably like okay, revert half the number. What?
How do you
know the half?
Yeah.
Well, I gotta God, shut up. How do you know the half?
Right.
How do we know we've reached the half of the number? Since we divided by 10 and multiplied the reverse by 10, when the original number is less than the reversed number, it means we've processed half the number of digits? Oh, that's clever. They compare the number they're making to the number of digits remaining. So if they start with 5 digits, pop off one of the digits, put it in another number, pop off another, put it in the number, so now it's 3 and 2. 2 and 3, that's how you know you've passed half by number of digits in each of the numbers. So you can compare them numerically. When this number is bigger than this number, it has more digits.
Okay.
Clever.
Fair enough.
Clever.
Yeah.
I like it.
Sure.
Yeah.
Oh.
Yeah.
Wait, it doesn't even do. It just reverts the number. And it sees if they're equal.
Yep. Because it's constructing the reversed left half as it goes.
Or x equals reverted number divided by 10? Oh, if there's like a 0?
I don't know.
Okay.
Huh.
Yeah, okay.
Alright.
I guess
Space complexity. Time complexity, log of n.
like the size of the number, really?
Fair enough. Well, log
mean-
log of n is the number of digits, so sure.
Yeah, exactly. Yeah.
I wouldn't call that log of n though. There's one input and it's a number.
Right.
I don't know. I guess it's log of n, but that's just silly.
Yeah. Alright, do we want to do... Oh, the next one's easy as well. I've seen it. No, it wasn't. Wait, it said... Wait, where did I see submissions? I swear it said that the next one was green. Let me see. It was after this. Look at that. Next challenges. Green.
Oh, no, it lists a bunch of like recommended related problems.
Huh. Got it.
Not the next problem.
Should we go for this right now?
Regex matching. Ooh.
Easy.
Ooh.
Not easy.
Actually, it's just a period and a star.
And it's fucking.
But.
Okay.
Honestly, though.
If you like walked into an interview, they're like, do this, and you're just like, okay.
Okay,
Important
I'll
read.
do it. Regular expressions.
Yeah. Alright, give it a pattern. Support for dot and star. That's it?
I don't know the fast way to do this. There's like a lot of complicated matching stuff that actually spins up the like automata. Automatons? That doesn't sound right now.
Mm.
And like does something. The finite state machines.
Mm.
We're not gonna do that.
Yeah.
But I also don't know like a fast way to do it.
Yeah.
I mean, is it decent enough to just go from the right to the left of the regular expression? No, it's probably still. Well, no, yeah. Because, well, maybe
Well, yeah, what if,
not. I don't know.
like, for the Mississippi, what if it was, instead of S star, it was S star S?
That would be a good case for going backwards through this.
Oh, backwards through it?
Yeah, because first we do a dot, match it, done. First we do a star P.
Okay, what if it was P, P star?
should just not
What if we rip out the single?
like try to match all the single ones first
Yeah, so like match the M, match the I, match the I.
and make sure those are still in order.
Oh, but we don't know which ones to rip out. Oh my God.
Right. Actually,
Can you do this with a tree? I feel like you can do this with a tree. A try? I don't remember what a try is.
sounds like probably not. I don't think you could.
Wait, why doesn't that match? Wait, M-I-S-S-I-S-S. Oh, there's no I.
S-S,
No second I.
I-S-S,
Or third I.
no I, P-P-I.
Yeah.
Yeah. There's this is bad. Do you think it's good enough to rip out all the single ones like M-I dot? Ooh, dot. M-I-I. So we see M-I-I. And now we know it has to be an S star between it. So...
Or we could go
So like we M-I-I, make sure that this is an S star.
Yeah.
And then continue.
We can recurse this, right?
Yeah.
To some degree.
I don't know if it's going to be efficient though. I'm scared
Yeah.
of efficiency.
Yeah, we can record from I what characters it is till we get to the next I.
Till we get to the next legit character.
Yeah.
And then make sure...
And then make sure that's a
yeah,
match.
so we can probably reduce something that handles dot star actual character to something that just matches sequences of stars. Like...
Yeah, we could.
So if it's like S star P star in it,
Or
we'll make a specific S star P star matcher.
I mean, we could just put it back into the same thing.
What?
Oh no, I guess you're right.
Yeah. And then I don't know
Okay.
what we want to do about dot.
I mean, yeah, we can do characters and then dot and then
star.
star. So like is match would do all three, but it like refers to the second one which does star and dot,
Right.
which refers to the third one which just does star.
Right.
Will that work, do you think?
Yes. I don't know about the dot. What do we do for dot? I mean, dot is almost always fixed. Like in this case, dot is at the end, so
Yeah.
we can match it and we're done. But if the dot is in between stars or something, I don't know. Like if it's A star dot B star dot C star. Ooh, yeah. Do-do-do-do. So, first it tries to match this. But I guess this could be an A, could be a B. It doesn't know yet.
Yeah. Or the C or next.
Yeah. So, I don't know how we want to represent, like, series of A's, dot, series of B's, dot, series of C's, to be easily checked. Without slow recursion.
Okay, hang on. After S star,
Uh-huh.
it's either... So if we have S's,
Yep.
Afterwards, we either have an S
That's matched by a dot, or we have.
or an S. So this can be represented by. So once we hit an S star,
Uh huh.
the three cases are
It matches all of them.
it's an S, it's a dot, or it's a different letter. Oh, but then it can continue on to S star again.
Mm-hmm. Should we just do it the easy way? Like the easy recursive way?
What easy recursive way?
Try every possible
try every
matchings from left to right. Yeah.
Yeah. Okay.
Yeah, like first we match an M, there's only one possibility. Then we match an I, only one possibility. Then we branch into two recursive calls, one where we've matched none of the S's, one where we've matched one of the S's, one where we've matched two of the S's.
Oof.
And then we continue.
Yeah. Is that N to the M?
I'm pretty sure it's not good. It's probably exponential. But also I think regular expressions kind of just are like that.
Oh, really?
Like you can make really slow regular expressions and there's just not a good way. But there's probably a decent way. There's probably a better than naive way.
Yeah.
I don't know. Maybe we could break it into like pretty fast matchers. Like if it's S star fixed character, pretty easy matcher. Like we can write that and it'll be fast. And we don't have to go through all possible S star matches. The only issue is if it's a dot. And yeah, so if it's a something star, something else star, that's also a fast matcher that we can do manually.
What, you mean like S star P star?
Yeah, S star P star, we can write our own special matcher for that. Oh, no. S star P star X. We can't do.
Right.
Man, this is
But well, okay, again, what if it's like S star S S star? Will overmatch with the S star.
Yeah, I know. It has to be a different X.
Okay, so S star X.
Is its own case. Like that's just like some ways to maybe make it faster. I don't know if that's the way to go. For us.
We can enumerate the cases. Do I just?
I mean, the issue is that there's like infinite cases. Did you? I think we took a picture of this stuff already.
We
did.
did?
That's new. Is that new?
I don't know.
Yeah, that's new.
Okay.
I'll get a picture of it just in case.
I feel like it's not infinite.
That is true. It's not infinite. We have fixed strings and fixed. Yeah, each string is a fixed length.
Let's start with X. We'll use X for different and S for base.
I also feel like going from the end is better, and I don't know why.
Yeah, maybe.
Going from the end, you don't have any ambiguity of how many you should match of a star. You have to match to the very end of the string.
True.
But is that the same in reverse? Because it could start with an A star.
Oh yeah, it could start with.
So I don't know if it actually makes a difference. It just feels like it makes a difference.
Feels like it.
Yeah, so all of our cases are like to the next fixed character.
Yeah.
That's all of our hard-coded stuff, I think.
Okay, let's.
Yeah, so
So S X.
first we match up to M, then we match up to I, then we try to match up to I. And then that boils down to something simple we can do.
Cut off MI.
Right.
Both, right? And
Yeah.
recursive.
Yeah.
Okay.
Right. And then we see, hey, look, S star I.
S star I.
We can do that.
Yeah.
And then we see S star P star dot, and we're like, oh goodness. Oh no.
Sorry. It's fine. I should have watched it.
Yeah. This one is
What?
sad because it doesn't know what the dot is. Except it can figure out what the dot is just because it's at the very end.
Yeah. What if we just cut from both sides or something? Just cut off the easy ones.
Just keep cutting off the easy ones from both sides. I
Okay,
mean,
so
like, yeah.
we can like MI.
let's use RE's match on the string we're supposed to be doing to break it into cases.
That would be funny. So this goes to
I think this example also just isn't complicated enough.
MISSISSIPI. I'm gonna put an I here just to pretend like it will work.
Okay.
So this goes to S star IS star IP
Star dot.
No. SS.
Oh, you did both sides, both ends at the same time.
P. Yeah.
That seems good, because then each side can go up to the fixed character.
Yeah. So this
S.
is easy unless it's like
Yeah,
S
unless it's not.
star S.
Yeah.
So it's either S star S
Although
or S
if it
star
is S star S,
anything else.
matching from the right is going to grab the S.
I'm gonna make Z for like literally anything else. Sorry, what?
If the whole thing is just S star S, it's easy. Because the S is at the boundary.
Right, and we'll cut that off.
And same for SS star, we'd cut it off from the start first. We'll do the cutoffs before we do the...
Oh,
yeah, we'll do fixed before stars. Fixed before dots before stars.
When you're going backwards, the same thing applies.
Mm-hmm.
S star versus Z S star. Okay, so we get that. ISSI. Then we cut off the I's.
Yeah.
Easy. Then easy.
Although, why didn't we cut off the I's during the star stuff? For S star P star? I would think it would cut off S star I as it does it up to the next fixed guy. Unless it doesn't, because what does it do if it has an S star P star at 1? Like, what would it do if there wasn't the I on the right?
This?
Or, sure.
Oh.
That's the left.
Oh.
But yeah,
you're right.
if it was
S
like
star,
this.
S star is different. No. Then S star, P star.
Yeah. So if it has this,
Then
the right side could do a match of a sequence of stars up to an I, because that's a fast thing we can program manually. But
yeah, we go here like. Oh wait, yeah, we have to start here. Be like, we're going all the way to I.
yeah,
Do we have to chain these like completely, or can we be like, or S? Yeah, it's or S, right?
what's or S?
Are we going through being like find all the P's and the S's until we hit I, or are we doing find P's until we hit I or S?
Oh, shoot. Yeah, well, right, because there could be no S's, so it has to go find all P's until I, and if we aren't at I yet, find all S's until I, and if we aren't there yet, then it didn't match.
Oh, because if we hit an...
Yeah.
Although, if we hit an S, then we hit this. Period. So it would be this is failure with I.
Yeah, right.
I.
But it's literally find all P's, done. Find all S's,
yeah, okay.
done.
So it's find all P's, success.
and then continue to find all S's until we hit an I.
Okay.
And we just keep doing that through all of the stars. I don't know about the dot though, because the dot messes up things.
Oh, if there's a dot somewhere else.
Yeah.
Okay.
But maybe we can pretend there's no dot. Maybe the left-hand side will get us close enough. There's a lot of ways to do this by just searching all possibilities.
Yeah.
I don't know how to do it fast. Should we just do it without worrying about dot and figure out how to do dot later? I think we can do this with like I think we can pretty easily do just star and just letters. Right?
I mean,
Like keep
the dot fucks up the star.
It does.
So I think we have to just like continue past the star and try to match it.
Try to
as
match
late
the
as-
remainder between the
as possible.
so keep matching things looking for the fixed number. If you hit a dot, save it and we'll come back to it. That's the way that works?
Sounds good.
Sounds not fun to program.
Okay, the thing is, P star dot.
Mm-hmm. But that's great because the dot's at the end. Dot at the
No,
end
no,
is a
we're
special
saying-
case. P star dot
We're saying there's other stuff.
Z. Okay. Yeah, so if it's going from the left to find a Z.
Yeah. Oh, it finds the Z, looks backwards.
Oh, that's true. Yeah, wait, what if initially... Oh no, I don't know. What if it finds the wrong Z? What if the Z was the dot? And stuff like that.
Wait. Okay. While we're going, we're gonna have a variable dot satisfy. Okay? We start with P, instantly dot satisfied. Alright? Because P star could be nothing. So we could satisfy the dot, or and then dot required.
Man.
Okay.
Wait, so maybe, what if we try to match all of the dots before any of the stars?
Then we hit a Z.
Can we try to match
Dot
dots
is
first?
satisfied.
Also, what about dot star?
Hit a Z again.
We're just gonna hardcode dot star.
Dot required. Dot star?
Yeah, dot star.
Oh, if it has a dot star, we just return true.
No, because it only accepts if the thing
I know.
between the things. So the left to right sounds good, but from both sides
Yeah.
sounds good. From both sides until the fixed character. Always. Maybe. Maybe. I feel like we should do it this way though, to try to be fast.
Yeah.
I think we should try for like 70% plus on this one.
Yeah. Satisfied. Oh, and we have to have hit. Okay. Hit equals false. So
Dot satisfied true. Required. Those are false. And then we hit this. We hit. That's true. Oh, and that's it. No. Then we keep going till it's required. Oh, fuck. But what if it just continues? Is this the P? Fuck!
I think the way I used to like doing this was you go through this thing one character by one character, and every time you hit a character, you go through the set of all possible regex stuff that could be remaining, and like if it's an S star, one set in the future keeps it being an S star, keeping the S, and one chucks this off of the regular expression. So you just have a set of possible different regex matches.
Mm-hmm.
I don't know if that's fast though.
Mm.
It feels fast-ish because it's always consuming one character from the input, and it's just maintaining a maybe shitty memory dictionary. But I don't know. Well, also, if the dictionary memory is big, then you have to iterate over it all to
Yeah.
split them all even into even worse options. I don't know.
Dude, these hearts, man.
I know. Brutal.
Brutal. Should we just like start?
Like
Or-
maybe. I don't know. It's
No, but what
if we
go
do
down the
it,
wrong
it's gonna
path?
get real ugly, real fast probably.
True. True.
So I don't know. I don't think we want to.
Yeah. Star.z. I don't know if I encounter a Z. That's the dot. Maybe we have to.
How bad is it to say like this is a set of fixed characters, this is a fixed character. No matter try to match this inner whatever it is, like P star S star dot whatever, for everything up to an I. So try to match SS to it, try to match SS ISS to it, and try to match SSS ISS IPP to it.
Huh.
And then continue. And see what of those matches the S star. And if there's only one, that's awesome. And then you continue. And then you try to match S star P star dot from the latest I. So try to match that with whatever shortcuts we come up with for the case, like there's a dot at the end or whatever. But just like keep going to the next fixed thing. I don't know.
Yeah.
That makes it pretty decently recursive, I guess, maybe. Unless it
Yeah.
doesn't.
Unless it doesn't.
But I feel like it does.
Yeah. Until they give us 1,000 dice in a row.
That's true. And they will. They will.
Yeah. Aw.
Isn't regular expressions by default greedy? Like, by default, it tries to consume as many S's as possible, and if that doesn't work out, it tries to consume one fewer S and retries. And if that doesn't work, it does one fewer S and retries. I think that's how most of them normally operate.
Huh.
That's why there's the, like, S star question mark to make it non-greedy.
Oh, really?
Yeah. But I don't know if we should make it greedy. I don't know that that's a particularly good thing to do. I just think that's how most of them are.
Would that work?
I mean, it would work. It would just be... It's just recursive as hell. It's recursive as hell, but it specifies the order.
But you have to backtrack.
Well, yeah, that's what makes it recursive.
Oh, does it
so
do, like, options?
Well, no, I mean, to try... You can program the backtracking however you want. I would program it so that it hits this, and first it tries recursing on consuming as many S's as possible. And second, it tries recursing on one fewer. Stuff like that. That feels kind of the same as maintaining a set of all possible regex matchings. But maybe faster.
Hey, I'm willing to try it. Should we?
Yeah, we could.
Okay, let's go.
Alright.
Fucking do this.
Let's
We're gonna finish this tonight.
What time? How late are we going?
11.
11. Alright, let's do it.
Let's do it.
Alright. Your mouse is here. If S at 0, no. If len of S equals 0 and the len of P is 0, we're done. Return true.
What about if there's stars?
Eli. I don't know an easy way to check that. Okay, or if P dot matches, if RA dot matches P of dot star.
No, we'll handle that case. Okay, if S at 0
is the...
Should we do lowercase English letters first?
We should probably detect if the thing that P is matching is a star, a dot, or a single character first.
Okay.
If P at 1 is a star, that's the only special case. Otherwise...
Wait, there's a dot though, right? Or are we not doing that yet?
If P at 1 is a star, that's the real special case. Right?
True.
That's then 0. Wait, whoa. What was...
Because this is len of 2 or more?
You're doing S and then you're doing P. And then you're also... Oh, yeah, okay. If that's the case... maybe spin up like an I0 and then
I0?
Yeah, and then like while s at I is equal to, I don't know if we want to do it this way. Yeah, we do.
Okay.
While s at I is equal to p at 0 or p at 0 is a dot. Equals. I plus plus. And also while I is less than the len of the s.
Up here?
Yeah, at the very beginning of it. And then I guess the first is it gonna parenthesize around the or is it gonna?
Yeah. Or
No, it's not. Alright, so now we just moved I a whole lot, and then we should try maybe the substring of s all the way up to it, consuming everything. So from try to return is match of s of I colon with the p of 2 colon.
Another one.
Yeah.
It's greater than.
Can we do just a for range starting at the bigger one? And no, yeah, I like this.
Okay.
If is match s of I colon comma p at 2 colon.
Colon comma. What? Wait, colon comma?
No, the comma's outside of this.
Oh my god.
P at 2 colon. Yeah. Right.
Be convenient. There you go.
I mean that
Love
seems kind of decent, kind of alright. Yeah, that's important. And then
Okay.
yeah.
Okay.
All right. Else. That's a good point. We don't need an else.
Yeah.
We just need to. If s at 0 is the p at 0, or p at 0 is a dot. Return is match of s0 colon s1 colon and p at 1 colon. Wow.
Why does it feel like this doesn't work?
I don't know really.
Huh.
I like it. I like it a lot.
Yeah, I mean it seems
It seems too good to be true.
too good to be
Is match
true.
is not self dot is match.
Where's what? Wait. Really? Wait.
Wait, is it normally control click on the?
Is it? Oh, it is. Okay.
I don't know. All right. Oops. That was in the last case? How does that work? Oh, maybe one of them's 0, but the other one's not 0. And so then on 14 it freaks out. Actually, yeah. As a second base case, can we say if the len of s is not equal to 0, but the len of p is 0, we'll return false?
What about if
Vice versa?
yeah.
I don't know.
Okay. If len of we should do this after because this has star.
Yeah, right.
Although this has I.
I don't know. Let's try.
Okay. If len of s equals 0
And P of S only contains alternating stars, and and P only contains alternating stars.
alternating stars? What?
Yeah, if it's A star, B star, C star, D star, but there's no dot or X on its own.
Wait, at this point, if it contains anything, right?
Oh, you think it's return true?
Because, wait,
No, it has
So
to
it
consume
doesn't
the
have a
entire
star.
thing. It has to consume the entire thing, which means that P has to be only things that are stars at the end.
but this, hang on.
Oh, it would
This
enter
takes
there.
care of stars
Oh.
at at index 1. So,
Maybe this case doesn't happen.
I mean, if P not if it fucking succeeds, but if it fails, like if S is empty and P has A.
P has just the letter A,
Yeah,
then it should return false.
yeah.
Alright, I believe it.
Okay.
What, you don't like it? What? First I starts at 0, and we want to consume as many as possible, so we want to start the substring at, well,
I think we need that.
one of S, that doesn't change.
Right, but
Well, one of S is good. We incremented I up to some number. Now we decrement it back down to 0.
right. I'm only thinking if S is empty, then this will
Oh,
break.
just in this whole code?
Yeah.
That's 0. Do...
All right. What about that?
Okay. Feels like a weird place to handle this case, but alright.
I mean, if you want to handle it somewhere else, I don't care.
I would handle it at the beginning and check for a series of
Here?
stars. No.
Wait, where? What beginning?
Just above this whole if thing.
Here?
Yeah. Just if len of S is 0, but the len of P isn't 0.
Oh, here.
I would just manually check that P only has something star, something star, something star.
Well, that's fine. The problem is here, is if it's S is empty and P has stars.
No, but I would do the return inside of that case. Right there.
Oh.
Yeah.
Oh wait, we can do it
Yeah.
here. If len of S equals 0, return self dot is match, right? SP at 2.
I like it. I like
Alright.
it. That's wow. Alright, yeah.
Okay.
That's clever as hell. Okay.
Okay. We did it.
Don't know about that one, but alright. Let's go!
First try!
11%. That's real bad.
Wow, we did this hard faster than like half of the
medium?
mediums.
I know.
Yeah.
Well, see, that's the issue. I feel what I thought was the case is that most regular expression matchers were just greedy,
Yeah.
and they just kind of had to do it this way.
Yeah.
But
Maybe not.
You can do it a lot faster, I'm sure.
I'm sure. Should we look it
Especially
up?
just, I don't know. I almost want to try our manual, enumeration of easy cases.
Oh yeah.
And I bet that would speed it up a lot.
Yeah.
Like if we just did that at the beginning of this, search for a non-asterisk character.
Uh-huh.
See, and saw if it was easy to match it.
Right.
Because the only reason it's slow is when it has to.
Yeah, I'm sure. I mean, we could like even just add on to this and take that, the star case as late as possible. You know, and shrink it
Yeah.
first. Yeah.
Right.
If we wanted to, though, I don't know if that like.
I don't know either. I can't tell if this is like a particularly bad, basic regular expression parser solution, and like, interview people would be like, okay, how would you make it better?
Yeah, I think so, and then we can. Damn, we could say like.
I like the memory though.
Same. Wait, do we use like anything?
No. Just recursion.
Recursion. We have like I.
Yeah. Recursion and a couple variables, a couple ints. Unint.
A single int.
A singular integer. That's the .03.
Dude, I'm sure people who got 100% like saw their memory usage and were like, we can make it better.
Yeah.
I don't know how you do this without I, but
I know.
yeah.
How fast do you think Python's built-in regular expression matcher is?
Probably a lot faster.
I want to see. I'm gonna
Alright.
check real quick.
Okay.
What is the match?
Oh, it's re. Import re.
Uh-huh.
Oh, and you're.
Alright, what's the like, is it just if dot match?
Did we end up using it for the previous one? No, we didn't. I don't know.
How to use regex in an if statement. Oh, look at that.
Oh.
If match is not none.
Alright.
Oh, I lost my character. Is it gonna complain at me that this P is a string and not a regex string?
I don't know.
That would be sad.
Yeah.
Wait, this is not none. I guess I will do this. Ah. Excuse me. Ari.
Wait, what?
Excuse me.
Oh, wait,
Alright,
maybe
match.
multiple matches.
Match entire string. Okay, you could use the carrot and money. Okay. Okay. That's the way to do it. That's the way to do it.
That's the way to do it.
That's kinda stupid.
Yeah.
Alright.
It's not even 90%.
No?
Wait, who makes red like the
Maybe-
library? Oh, because it's doing more than just.
It supports
dots and stars.
way more. Yeah.
Right.
So I based on that, I assume there's a pretty decent solution to this
Yeah.
that is decently fast.
Assume so as well.
But I can't think of anything else other than like cases of
Yeah.
specific simple matches.
Yeah. Same. Should we look it up? See if cases is the answer?
Maybe. I don't know. I don't expect recursion.
Clean stars.
Ah, yes, this star is called a clean star. Wow.
Yeah, it's like, yeah, that's literally like the 2 lines we have at the end.
Well,
Like that. Yeah. Pretty much.
well, how did theirs? Oh, without a clean star, our solution would look like this.
Yeah.
I did not read that. With a clean star, it's uglier. That's a weird asymptotic.
T squared plus
Space?
T squared.
Wow.
Oh, that's
Dynamic programming. As the problem has an optimal substructure, it's natural to cache the intermediate results. Do we ever have intermediate results? I don't think so.
No.
Unless we do, because multiple ways of matching the first bit could have already worked out the matching of the last bit. Consuming stars versus S's differently at the beginning. I'm gonna try Python memoization decorator. Dope. Memoize.
what is that, dude?
Memoized. I just want to do it. Import func tools. There we go. It does memoization automatically.
Oh,
Beautiful. Look at that. Beautiful.
wait, what?
Yeah, just cache the results, because I guess the different matchings of the beginning is gonna reuse the matchings at the end a lot.
What does that mean? I don't know
Okay,
what you're
okay,
talking
okay.
about.
So if it's like S star S S P S star dot or something like that.
Okay.
First, and our string is like S S S S S P S star dot. This isn't gonna call this multiple times, is it?
Well, your string you're searching has an asterisk in it.
Oh, look at that.
It almost matches, but the dot would have to be used for that. Anyway.
So this would first try to match PSSS with SSPSS.
Uh-huh.
Bad.
True.
And then it would try this. So this is not an example of where it would work. There are cases where it calls the same thing multiple times.
Same thing multiple.
Yeah, it calls. Well, that's what memoization does. For a fixed S and P, now that gets saved in the LRU cache. Every time we call this with the same S and P, it returns it instantly and doesn't have to do our recursion.
I just can't think of an example when that would happen.
I know, right? But I guess it does. What if it was like this? Nope. Does the solution say the examples for when that happens? It is natural to cache intermediate results. Oh, look, Momo.
Oh! When
You got one? We should probably just remember to memorize problems like this just to see if it helps in general.
So if we have like then it starts out matching
all the S's
this.
and then gives up real fast. And then matches up to that S.
Okay, let's do
I can't think of a example of this.
and then it gives up. So it goes to this.
What are the odds we can like see the test cases that it runs?
Oh, I almost have it.
It's no.
Oh, it have to be like where it gets close and has to try again or something.
Right. So maybe try something where just the last character doesn't match? Is that when it happens? No, I don't know. I can't think of an example.
It has to be where it like cascades a mistake.
Yeah.
I think like P star.
Can we just like
Dot
look in the code where it could return?
P I star P I
This?
and then a whole bunch of shit.
Yeah, is it this line here? So if it goes after something that's clean starred,
Yeah.
this will have already tried the chopped off string with the skipped bit of this. Even if this fails and we arrive at that same substring by chopping off it differently. Right? Or maybe not. I don't know.
Yeah.
That's the only line I can see that would do it, I think.
Yeah, we arrived at that differently.
Yeah. Because I think this one always is just the same. This one always reduces it, but this one could be called multiple times.
Oh, it's
Maybe
the
not.
short circuit's a fuck up.
Yeah.
Yeah.
Yeah, if it's trying to fuck up again in a different way. Somehow. I don't know.
Yeah.
I like Python though. We can just memorize
Yeah, that's pretty great.
That was the easiest hard we've ever done.
I swear I've got this.
Oh,
I just erased everything.
Oh. I wonder how much of this code we can throw out.
True. I'm gonna Sit on the couch. With my handy dandy. Whoa,
Mini whiteboard.
Yeah.
Wait a minute. Do these two cases ensure that P is always bigger than 1?
No.
You sure? You sure I can't delete this bit?
Uh-huh.
Why?
Pretty sure.
Oh, bigger than 1.
Bigger than 1. Yeah.
You don't do the greater than or equal to 2.
It depends.
Actually, I bet since now we're memoizing, we don't have to do the greedy solution first. Right?
Maybe.
Or maybe not, I don't know.
I don't know. API.
I think greedy first is better. I like how that sped it up by 10 times though.
Yeah. Yeah.
I feel like we cheated and looked up that the optimal substructure thing.
Optimal substructure?
It's like it's natural to cache the results, and I'm like, oh.
Yeah, I don't feel like that's very cheating. Alright, what if it's like super long and like obviously fails? You know, if like but then it like
So P star I is gonna do this whole thing, and then it's gonna try this with a PI, but it already knows that a PI fails with a I don't know. Never mind.
wait, give me a shit ton of S's. Hang on.
Oh.
Okay, so once it does the first try, okay, so like, okay, first it does greedy, where it tries to match, it tries to match this with this. It's like, no, okay, go back one, okay. It tries to match this with this, but eventually it gets down to here. After it's succeeded, right? Yeah, it has to like cascade mistakes or something.
Something like that.
Oh my god.
The regular expression thing needs to get the same one if that needs to get checked multiple times.
So weird.
It's just weird because we're always recursing on P at 1 colon or 2 colon. So it seems like we're never repeating the same thing. I don't know. But I guess nope, I don't know.
I don't know either.
It's only 10:25. It's 10, like last time I checked.
Yeah.
No time at all.
really annoying. I can't find a single example.
I know. Is it something where... No, there's no parentheses. Is there something where it's like star star? S star star? Do we even support that?
No, we don't.
Right, because we would get left with a star at the beginning and we'd be like,
Yeah.
don't know what to do with that.
Is that even valid?
I don't think it said it
It
was. Not in this. I think it is valid regex, but
How?
S star is in parentheses.
Wait, can you star multi? Oh.
Yeah. It's a really easy way to make your regular expression really slow. I wonder if we tried to rewrite this whole thing in like a table form, if it would make more sense which ones overlapped. I don't know how we'd write that though.
S star
I don't know, everyone's just like, and you memorize. It says there are m times n possible subproblems, one for each combination of the suffix of the regex and the suffix of the original string. Then why would memorization magically make ours faster? Oh, because ours does explore m times n. It just used to be worse. It used to be some exponential. Aha! Do smaller subproblems get repeated in the recursion tree?
No, they don't.
Wait. Maybe let's first understand the problem solution. When does it repeat?
Never.
Maybe it's dot. I bet dot causes it to do it.
Yeah.
That's gotta be it.
Why would there ever be a case?
Aha, I got one.
Did you really?
Yeah. Really bad one.
Okay.
No, I didn't.
Dot star matches to the end. It tries to match S star with squiggly. Alright.
It needs to call this multiple times. I can't think of anything we can put at the beginning that would call this multiple times.
I know, right? How do you fail multiple times in the same way?
What would we call this multiple times? Is it just everything for which there's multiple valid matchings of it? Like if the same regex could match the input in different ways?
Why would it be? Oh, where you can match it the same.
Like what about this? It either takes one of each and nothing, or
Well, let's see what it does. It takes A, then it takes B, then it takes C. What does dot star do?
matches as many as possible.
Does it? Yeah. It takes SS, then it takes... Do we have nothing?
What?
We do. Then it... I feel like we don't have nothing. If it matches nothing.
I still feel like this doesn't hammer this same test case very much, though.
I feel like it goes through it once and it never backtracks ever.
True.
So if it doesn't backtrack, it would be impossible to use memoization, right?
I don't know. I'm confused. In the recursive version, there are some overlap subproblems we can optimize. Give us a singular example.
One example. Just one. Just...
Like a single example.
I just want one example. Shoot myself.
Why is it? So, it's gotta only happen when it fails, right? Like the overall thing is false is when it
Yeah.
is hammering something.
Maybe dot star connected with other star.
Yeah.
Oh my god.
Huh.
Oh! Or if it's just like fucking P star. No.
Nope. The input string's different every time.
Yeah. It tries
It
this,
tries
and it tries
E with
this,
nothing,
and
and then
this.
PE with nothing, and then yeah. This is infuriating.
But maybe dot star P star though.
Yeah. Maybe.
Let me see. So it takes in everything, then it
Oh
compares
yeah.
P star with
P star
E,
with nothing.
with E.
Okay. Yeah. P star with E.
'Cause
No. The dot star would take the E too,
you're right, you're right. P star with nothing.
which returns true.
Okay.
The answer is true. And then it's done. do like a D at the end or something maybe. Yeah. So it does.
Oh wait, P star D with nothing.
So it does P star D with nothing, which is D with nothing, which is false,
Oh yeah, D with nothing.
which is false. Okay, and then it backtracks and tries a different number of P's.
It must no, because this
No,
sure
this
it
wouldn't
tries
try any other
different-
P's because there are no other P's, and then it has to try a different number of dots.
different number of dots. So,
So
it
it
tries
would try to dots match all the P's, and then it would try to match P star D with E.
oh. P star D with E. Which is D with E.
Haha, we have a case that we've already computed.
Where? This is E.
Oh, is this empty?
Yeah, that's empty.
Oh, dang
Okay, then this gets those. It does P star D with PE. Oh? D with E!
Haha! Wait, what? It was P star D with
D?
What?
Wait, what the fuck is...
what did you do? It was P star D
With PE.
PE. Yeah.
Yeah. P was P and now it's DE again.
Haha! An example.
Holy shit.
Alright, now we believe it.
Now we believe it.
So I bet this happens a lot because
Dot star.
this happens a lot.
Yeah, yeah.
Something, yeah. Dot star, A star.
Okay, we did it.
Kills the whole problem.
We figured it out.
Alright. And
Shit.
I think we're content too, right?
Yeah. I'm pretty content.
It probably could, probably could optimize it a bit more, but
Yeah,
like, nah.
yeah. Nah.
We've arrived
So
at
is this the
limitation.
correct solution then?
Yeah.
This with memorization?
Well, yeah, it's
oh,
like,
and with memorization?
yeah, it
because
says, just dynamic programming. Just do it. Yeah.
Just do it. Well, I will remember that. Then
Yeah.
You can just like put a tag.
Yeah, we have to remember two things. We have to remember probably we should try memoization on problems like this where we're recursing and stuff
Yeah, if we're
and like trying options and yeah.
yeah, if we're recursing, yeah, and we might
And
the same.
also, we need to remember that we're probably going to get asked on like the complexity of this with memoization and without.
Okay. Is without n squared? Wait, no.
I don't know.
So with is mn.
Yeah, with is mn because that's the only possible inputs to the function. And we will cache at most all of them. Yeah.
Okay.
And then...
And that's len of s and len of p?
Yep.
Got it.
Yeah, because we're only ever chopping off from the beginning of either of them, so...
True.
Yeah. And then... I don't know what the runtime of the original one was. Wasn't it something weird? Was it this problem that had some like whack ass runtime for the
Yeah, I think so.
naive?
It's like
Yeah, it's like freaking this shit. A sum of a choose of an O of something. So
this is bounded
with
by
some effort, it's the exponential. 2 to the
it is exponential.
yeah, 2 to the sum of the input strings, kind of.
T plus p to the 2 to the... Wait, is that to the 2 to the...
Yeah.
Wait.
Times 2 to the
Times 2 to the...
t plus p over 2.
Oh, okay.
And those are the lengths of s and p, respectively. The text and the pattern.
Mm-hmm.
So... And the space complexity is t squared plus p squared. Because of course.
Of course.
Yeah, I don't know what the deal is with that. How did they do this? Match text from 1 colon pattern of 2j colon will be made I plus j choose I times. Oh, that's an example of how we get the repeated ones. This gets called I plus j choose I. I can't think of what that would mean in this case. I plus j is the length of them combined. Choose I is...
That's weird.
Weird. It's how many ways we can intermingle the star choosings? Is that kind of what it's doing?
Maybe.
Kind of feels like what it's doing.
Yeah.
Number of ways to match star choosings. That's my guess.
Mm-hmm.
Answer, exponential. Bad. I don't know. I don't think I would be able to figure out it's 2 to the something.
Yeah. I'm sure if we just say exponential, it'll be fine.
Yeah. Cool. Should we see what the next is?
Yeah.
It's 10:44. Let's do it.
If it's any easy, you can breeze through it.
Onward, medium.
Ooh,
That looks like a familiar diagram.
I know.
Given n non-negative integers, where each is a coordinate at I, a sub I, n vertical lines are drawn such that the two endpoints of the line I is at I, a sub I, and I, 0. So we draw a line from the 0 up to the top of the number. Find two lines which together with the x-axis forms a container such that the container contains the most water. You may not slant the container.
Oh, damn.
That would be complicated. So iterate over all possible pairs, but you can probably do something clever with a heap or dynamic programming. What runtime do you think this is? Probably linear. I would assume.
Mm-hmm.
It's like the maximum sum problem, right? Of the maximum sum of two numbers, or something. No,
So,
it's not.
I think once you find two of them, you can bring the lower one in and see if that's bigger, and keep doing that until you find one that's bigger than this one, and then I think you can just keep doing
Oh, just like start at the out, work in, because going in is gonna reduce volume. Maybe. Oh yeah. As you move a pointer either inward, either it jumps up and the overall volume increases, or the overall volume decreases, but you're still taking the maximum of the two. Yeah.
Yeah. Well, I wonder if...
How do you bring them in, though? Because at this problem, if you started with the right and brought the right one in, you instantly lose the solution. Or maybe you just never bring it in. Oh,
wait.
Is it just like, while you can increase the volume, move the pointers inwards to increase the volume? Or
No,
would you
I
miss some? You'd probably miss some.
I think you just keep track of the max volume and just always move the smaller one in.
Just the left-hand side one?
No, the smaller one. Like the one with the shorter height. So...
Always
right
move
side.
the smaller one in. Keep track of the overall maximum.
Yeah.
Huh.
Do you think that works?
So, from the reds that it's highlighting right now, you would bring it in from the right,
Yeah.
and that just happens to be less than the overall volume, so you don't care.
Yeah.
And then that one's still lower than the left bound, so you bring that one in. Huh. Does that work? Yeah, because moving in one direction removes the same volume, like, removes the same amount of width, but you want to remove the least height, I guess. Or
Yeah.
maybe not.
Yeah, I think so.
Yeah, well, if you're to choose between this and this, whichever one's higher, regardless of what this guy is or this guy. Is that true? So if this guy was like super high, you would want it to be that one and that one. Versus if that one was super high.
Oh, yeah.
Oh no, if that one's super high, you would want to choose that one.
You're right.
Shoot. Still feels pretty right though. Kind of.
Wait. Okay, give the counter example again.
This guy here,
Uh-huh.
really high.
Uh-huh.
Massively high.
Uh-huh.
That's it.
That's, it's fine.
It's fine?
Because the one to the right still has the maximum height.
But this one has a height higher than this one.
Okay.
So it's going to bring this one inward.
Okay.
Do nothing because... and then this one's smaller. Bring it inward.
Okay.
We choose this one.
Maybe, yeah.
Or is this one higher than this one? They're the exact same height. So we'd move this one inward again.
Uh-huh.
This one inward again.
Uh-huh.
Inward.
Uh-huh.
Find the super high one.
Okay.
And it would think that's the maximum volume instead
We'll
of
calculate it.
that.
No, but that's not the maximum volume.
What?
So this is not the maximum volume.
No
Even if
way.
that's super high. This
you
is still
sure?
the maximum. Because this doesn't get any higher.
Yeah.
Yeah.
Yeah. That's a shame.
It's a shame, or is it convenient for us?
It's super convenient. So, if we have two things, you can only ever increase the volume by bringing the smaller one above the larger one.
Yeah.
You can't do it by you
literally,
can't do it by making this one anything else because it's already bigger than it.
It's
It's
already
already bounded by the small one. Yeah,
It's
yeah.
already bounded. Yeah.
Yeah, cool.
Okay, easy. Okay.
Yeah, easy. I0, J is that how that works? Can you do that?
I don't know.
J is the len of height minus 1. And go ahead and initialize the mx to be the minimum of the height at 0 and the height at the -1. And then times the difference between 0 and the len. Times len of height. Sick. Alright.
-1?
No. Yeah. And then,
Should we have a base case?
what, are you going to recursive this?
No.
Oh. Oh, I mean, yeah, we probably should, but I don't, it doesn't matter. If the len of height is 0. Return 0. Okay.
Okay.
Well, true, I guess. If height at I is less than the height at J. Actually, can we initialize this guy to -1? And then when we decrease it, it goes to -2. And then it still works. No, we can never check if they like cross each other.
Yeah.
We would want that.
Yeah.
Alright. If the oh yeah.
Okay.
Height
I is so I plus plus.
Yeah.
Okay. Oh, should we do the check here? Or
No, just check after because
we already have it.
Yep, exactly.
Um.
Else J minus equals 1. Alright, and then if the or I guess mx equals the maximum of it just wants the maximum height, right? Yeah, it does. Sweet. Maximum of mx and the same thing that we can copy paste from line 5.
Oh. Whoa.
Yep. And then instead of 0 and -1, it is going to be J and I, and then it's not the len of height, now it is the J minus I. Plus 1? Is it plus 1? J's inclusive.
I don't know if it is.
If it's 0, 1, 2, it's going to give a width of 2.
If it's 0 and 1,
It's going to give a width of 1, which is correct.
Yeah.
So then why is it len of height instead of len minus 1? I don't know, that's weird.
Wait. Is it? Wait, if you have 3, that's
1,
a width of 2.
2, 3.
It should be -1.
Yeah, shoot. You're right. Boop. And return mx.
Do you think?
Alright. It feels good. Good. I think so.
Yeah.
I have a feeling.
Good. Well, there you go.
Faster than 31. That's bad. How is that bad?
I don't know.
Spamming the min and max functions?
Maybe.
Probably.
I'm gonna change this to an if and see if it makes it better.
Oh yeah. If
Oh, wait,
if h colon equals. If h colon equals min of these boys is greater than mx, mx is h. Delete. Run. Huh. Excuse me.
That's funny.
Oh, parentheses around the h colon equals. Or around the argument of the h colon equals. Colon
This?
equals parentheses.
Really?
Yeah.
Like that?
You want the value? No. Delete the left parenthesis that you just added, and shift it to the right 4 characters. Yeah.
I see.
The value of that.
Like, wait, what?
Yeah.
Okay.
Unless we need another one around the greater than, but I don't think the h is being set to the result of the greater. Oh. Okay.
Wait.
Maybe you're right.
Okay. Like that?
I don't know. I don't know what the level of h is. 45. I don't remember what it was.
It was like
That
30
was
something.
a little faster, but not really any different at all.
Yeah.
Why is it? How could we make this faster?
Okay, it's like the same.
That's weird.
Interesting. Wait. Honestly, what?
Yeah, this seems as fast as you could possibly do.
Maybe it like short circuits.
Maybe it stores like the current level.
Current level?
Yeah, the current level of the water, of the height. Instead of spamming min a bunch, it always has it only once you do this, you maybe update the level based on the new thing you've considered. Do you think it's actually, do you think you could replace this with like while? That might be faster. But it kind of does it already.
Yeah, and what if you find the max and you miss it?
You won't. If you never increase in height, you
Oh.
and then same for the else, I guess.
What if
What if you don't have to store the actual volume? I feel like you do. You have to store the actual volume.
what if it finds something higher and then immediately finds something else?
Yeah, I know. So probably copy paste this up 2 lines. Yeah.
Interesting. What if we get this case?
I don't know. It won't happen.
Definitely not.
Mm-hmm. Whew. Feels slower. Or wrong. Yeah.
Ooh, really?
Infinite loop. Wait. You didn't flip one of the signs. Yeah. There we go.
How? What?
I don't know.
If they're ever... No, never mind.
I don't know. What
That's
if they're...
weird. Why?
I don't know.
Why would this happen?
I don't know.
Oh, equals.
Really? Oh.
I'm
Okay.
sure I can put equals on only one, but I think this will make it. Ooh.
Man, this made it sad.
I told you. You gotta.
I don't know. Weird stuff.
Shot up above the plane. Alright.
I still feel like this is like the fastest.
I know.
I don't know.
How is this 40%? What the fuck?
Right?
Oh, do you think this is one of those where just like the best answers just spit out the right answer? or whatever?
Hard-coded the answers?
Yeah. No, probably not.
Why not? Not 40, not 60% of them.
Yeah.
I'm like kind of content with it though.
Mm-hmm.
What if we don't do this calculation? Are we duplicating that calculation? Nope.
I don't think so.
We're not. Yeah, this is weird. I don't know.
Maybe all of these accesses to the. I don't know how else we would do it though. Okay.
Do you think you could like?
Oh wait, no. We only do one access like every time.
Do you think? Yeah. Oh yeah. There's 2 accesses per time.
No, but this is before the.
Ah shoot.
This.
You're right.
Alright. I'm gonna try this. I'm sure it's not faster.
Certainly, it's not faster. Literally identical.
Literally identical.
Okay.
Wait, but most of the time they weren't getting 152s. Okay, it's the same.
What if in the if and the else we save the new height that we're checking?
Oh. What do you mean?
So if height at I is less than height at j, I plus equals 1, h equals height at I. And then same for the else, h equals height at j. And then, oh shoot, I did h again. HH. For both of them.
For both what?
Uh-huh.
Do we have an H?
Yeah.
Yeah.
We'll make like an overall.
So are we changing this to HH?
Yeah, it's gonna be.
Wait. Because we need to get the new.
The min of HH, comma, HHH. And then we're gonna maintain the max height as we go. No.
No?
We're just gonna maintain the overall level. No, I don't know. This is stupid.
Okay. I don't know.
I can't think of a better way to. That's weird that ours is significantly slower.
Yeah. Do you think you can do it recursively? Is recursive faster?
No.
Okay. I didn't think so. Unless you memorize. No, you can't memorize this.
Yeah. Like, I don't think we're checking height more than we need to. We're checking height at a given index once.
Yeah.
That's pretty good, though. Well, I mean, I guess, like, if height at I doesn't change for a while, we're hammering this a bunch.
Right.
That's why it might be nice to do the, like, max height and only update the max height whenever we...
Should we try it?
Sure. Yeah. Max height equals the... I guess the max of height at 0, height at -1. Or just height at I and height at j. Max of max height, comma. Or say if height at I is bigger than...
You're right.
But then, how does this help us?
And what about the min height?
I don't know how this helps us.
I don't know how this helps us. I bet it does the opposite of helps us.
Yeah.
Did you delete it?
Yeah. I'm pretty content with...
Yeah.
You wanna look up what's better than this? Just to see why we're bad at Python?
Sure. Go like 2 point. Deductive proof 2-pointer.
This is dumb.
Why aren't they doing?
Brute force. No.
Oh boy.
2-pointer. Yeah? Yeah. Did they program it better than us?
Wait, do you think?
Max area LR. While L is bigger than R, max area is the max of the max area of the min of the height at L times R minus L. If height at L is less than... Wait, that's literally what we wrote.
That's literally the same thing.
Actually, wait, I think we can get to it from here and clicking this boy.
Ah.
Excuse me.
Fucking. Excuse me?
Excuse me?
Michael, you're gonna have to explain to me how this is in any way faster than ours.
Wait, I want to actually, like, try it. I want to try it. I don't believe it. There's no way. Did I copy everything?
Wait.
No, I didn't.
Don't replace it, just comment it out.
Uh-huh.
Okay. Like, literally the same code.
Uh-huh. No, actually, ours is way slower. Excuse me? LEETCODE?
They just hate us.
Sample.
108 milliseconds?
Yeah. Maybe this guy just hammered the thing until he got a good score.
Maybe.
This is so dumb.
It's literally
okay.
the same.
What about this guy?
It's the same.
There's one way to do this. Oh, this guy. How do you get over here? Sorry, is this...
Honestly, it's actually the same.
Wait, runtime 168. Wow. I guess the difference in their thing can just vary by a solid 50 milliseconds, which for this problem is like a lot, I guess.
I guess.
I mean, I want to like submit it a lot to be like, why?
Yeah. Wait, do they have different base cases
Getting
and
slow.
shit?
I think they don't do this calculation. They don't do this. Let's see if we can remove this.
They don't do
That 50 millisecond check. I don't actually know. I didn't remember.
Yeah, it didn't save us any time, but okay.
But okay.
Okay.
So they do this later. And I don't know why they keep doing like this stuff inside the if or else.
I don't know.
Like that wouldn't make a difference, would it?
I wouldn't think so.
I'm a little confused. Hey, that's a better one.
Yeah. Wait, did they like not have this? Wait, how did they... Hang on.
Yeah.
Max area is 0. Oh, and they calculated beforehand.
Yeah. Which is what we did.
That's what we did.
Of last times last minus first.
Oh, because they don't do min.
Yeah.
Because they know what's the...
Oh, they know which
and
one's the
if it's
min.
before...
Yeah.
That makes sense. Okay.
Except, wait, no.
Because they know height of I is the min.
No, they don't, because we just updated I to be something else.
But that's why they're doing it before.
Oh, yeah.
Okay, slightly faster. Ah!
Oh.
I am not double clicking, I swear. And then we don't have to do this.
Really? Wow.
We might have to do mx equals 0. I don't know.
Probably have to do MX equals 0. Put it in the function.
In the... No.
Okay.
Wait, do you know this is faster?
I don't think it matters. Although it looks real weird that you coupled the I and the MX, but not the J.
Not the J.
Yeah.
Also, you just have to... 144 this? Okay.
That's identical.
40.
57. Look at that. Getting there.
Yeah.
Maybe they all just have LeetCode Premium and it's 40%.
Yeah, maybe. First time, max area.
Go to one of the like 130s or something. I feel like these guys got lucky, but what about like, yeah. Oh my god. Ah, they did the wild thing. He got it working. That's what I was thinking to do.
Interesting.
Yeah.
And right index. Left.
Whoa.
Wait.
And right index? Maybe right index can go to 0? And they don't like that. I don't know. Widget. What about one slightly faster than this?
Uh-huh.
Ooh, I like
Look,
this.
they use max.
I like this one.
Yeah.
That's identical to what we did, though.
Mm-hmm.
Right? I kind of want to put it back to the first one we did, just because.
Yeah, alright.
I'm going to.
Okay. We lost undo history. That's unfortunate. This is what we like very originally had, right? Oh no, I broke it. What'd I do?
Invalid syntax?
No. Wrong answer.
Oh. The default for Max.
Oh.
Max. Yeah.
This was -1. Yeah. Whew. Yikes. Yikes.
Yikes.
Wow. So I guess it's pretty bad to do it like this.
No. It's literally like the same.
Well, it's like consistently 20 milliseconds slower.
Right, but just 20 milliseconds.
Yeah, wait. Did the if make a difference?
I think it did. Barely.
Oh yeah. Now we're getting the 150, 156, 160.
Hell yeah.
$168. I feel bad if it's like actually kind of slower. It's just this line, right? This is the only thing that makes ours worse.
Maybe, I don't remember. I thought it was, did pretty much nothing when we took it out, didn't it?
I don't remember. 1 fewer calls to min. Oh dear. Huh.
Can't set MX every time.
Hold up. Hold up. What's happening? Min of that times that.
Wait, you're setting max every time.
I know. What? I just wanna. I don't know. I think I'm content with how we did it originally.
Yeah.
Yeah?
Yeah.
Successful. LEETCODE day.
Yeah.
Got through a lot of problems.
Yeah.
New personal best.
Yeah. One of them was even hard. Or was it 2 of them hard?
I don't remember. What else did we do today? Our longest palindromic substring. We got linear because we're geniuses.
Hell yeah.
Took us 2 attempts. And then it was way easier than we thought.
Yeah.
And way better than friggin' Manicure.
Fuck Manicure.
Yeah, fuck Manicure. And then we did this guy, which was fine.
Pretty easy.
This guy, which was
Kinda dumb.
dumb. This one, which is quite dumb.
Quite. Yeah, quite
This
dumb.
one was
Just
also
ridiculous.
pretty dumb.
Yeah.
I love the way we did it. Definitely
It's very unique. I think, the way
Definitely
we did it.
efficient.
Very. Yeah. Definitely that.
Yeah. That one was
Yeah, I mean, we got
like
the
nice
answer.
that we it just
And
popped it worked.
yeah.
It just worked.
It just worked.
Yeah, it's great. This one was
Super easy.
pretty easy.
Pretty.
You
yeah.
can you need to only ever you never want to decrease. You never want to remove the possibility of filling up more than you currently are. That's what we were going to say then. That kind of dumb that the code runner is kind of dumb. But yeah, all right,
Yeah,
we did it.
we did it. Yay.
Well, we are now. Whoa. We are now 0.67% done.
Oh, you took care of the percent.
I took care of the percent. We're
0.67%.
0.67%. Look at that.
Making great time.
We're almost at our first percent.
Yeah, wait, that's great.
Yeah, so if 1% is
A week.
3 sessions,
Mm-hmm. Well, if we're
or yeah, a week.
a week.
1%'s a week.
It's 2 years.
2 years.
Maybe we should start getting faster at these.
I think we will get faster at these.
Uh-huh. I
Like
mean,
today, we're already faster.
Yeah, true. But it's also like a choice because with the easies.
Yeah, we could either do them the stupid way
Yeah.
or go through the way they're going for.
Yeah. I mean, alright, go back to the palindrome one or whatever.
The integer palindrome?
Yeah. What did they want us to do?
I don't know.
Just convert.
Oh,
it
they
to-
wanted the kind of clever,
Yeah.
with math.
Yeah. Oh, the funny thing is we didn't even think about that.
Yeah, I know. That's actually
Right.
that was actually kind of smart.
Yeah. Okay, that's fine.
Yeah.
What was the previous one?
Oh. String to integer. Dumb.
Yeah, this was just dumb.
Yeah.
But like, alright, what was the one before this? Reverse integer.
Math
Oh yeah.
that
was
we did
fine.
with recursion, so it was slow.
Yeah. Why? Why did we do this?
Instead of what? Because it was easy to think of the answer. It was easy to write it like this.
Okay. How fast was this? Okay.
Oh,
Oh,
96. Yeah.
Because, like, if we did it with a loop, it would just be so much easier.
Nah, I disagree.
You disagree?
How would it be easier with a loop? Yeah, it would be easier with a loop.
Yeah.
Yeah, because it's just literally doing this
Yeah.
until x is
Wait.
0.
I almost feel like we can do this in one line.
That is true. I mean,
I think
we
it
can
has
with
to
like
be
a
two.
ternary.
Oh, we can do this in one line.
Yeah.
But I
Oh,
mean,
you mean like
the
with one
for
while loop? One for loop?
But. Oh, wait. If we
Store if it's negative first.
store if it's negative. Oh, shit.
Then have one loop that keeps dividing x and keeps adding to the output. And then we return the output clamps
okay, so
to
maybe
the
it
thing.
wouldn't be much smaller.
It would be exactly the same.
It
Just
would be
like
except the if x equals 0 with the return would just be one line, which is like out equals
it
0.
would be built into the while or what? Wait, what? This thing?
Uh-huh. No, like,
This thing.
oh,
Oh, what?
shoot,
Look
I
at this.
forgot about that. Okay, never mind.
Yeah.
It would have just been like easier conceptually or something. Oh.
I think LeetCode gets slow at nights.
Oh, do you think that's how they did it? They just like ran it at like 4 a.m.
Yeah.
That's how they got the
Probably.
102 milliseconds
Probably.
for that other one. Yeah.
Yeah. That's funny.
Okay. Well, good night. It was a good night.
Yeah. Success.
Yeah.
We done.
But I remembered. You need to take out the trash.
Oh, yep. That's true.
I'll do that.
Alright. Stop streaming.